Good evening, and welcome to this comprehensive exploration of one of the most intriguing mysteries of our time. As you settle in for the night, we invite you to journey with us through the fascinating world of unidentified aerial phenomena, commonly known as UAPs. Tonight, we'll explore 3 decades of official investigations, government programs, and the scientific pursuit of understanding phenomena that have captured human imagination for generations. This is not a tale of speculation or fantasy, but rather a careful examination of documented cases, official reports, and the evolution of how our institutions approach the unknown. Our journey tonight will take us from the early days of modern UAP investigations through the recent renaissance of official interest. We'll discover how what once lived in the realm of speculation has now become a subject of serious scientific and governmental inquiry. So, as you prepare for rest, let your mind wander through these carefully documented accounts and official investigations. Let us begin with understanding what we're actually discussing when we speak of UAPs. Chapter 1. What are UAPs and why they matter, defining the phenomenon in the quiet of the evening as we look up at the star-filled sky? We might wonder, what exactly are we talking about when we discuss UAPs? The term itself represents a significant shift in how institutions approach this topic. NASA, the Pentagon, and other governmental agencies now use the term unidentified aerial phenomena rather than the more familiar UFO or unidentified flying object. This change in terminology reflects a more scientific approach to the subject. The word phenomena encompasses not just objects, but also lights, visual disturbances, and other aerial anomalies that don't necessarily fit the traditional concept of a flying object. A UAP, in its most basic definition, is any object, light, or visual phenomenon observed in the sky that cannot be identified as a known aircraft, weather event, or natural occurrence. This definition is deliberately broad and scientific in nature. It doesn't presuppose an origin or explanation. It simply acknowledges that something has been observed that remains unexplained after initial analysis. The scientific approach, what makes the current era of UAP investigation different from previous decades, is the emphasis on scientific methodology. Rather than dismissing reports outright or accepting them without scrutiny, modern investigators apply rigorous analytical processes. They examine radar data, pilot testimony, photographic evidence, and sensor readings with the same care applied to any scientific inquiry. This methodical approach recognizes that UAPs might have conventional explanations that simply weren't immediately apparent. Weather balloons, experimental aircraft, atmospheric phenomena, equipment malfunctions, or optical illusions could account for many sightings. The goal isn't to prove or disprove any particular theory about UAPs, but rather to collect reliable data and analyze it objectively. Growing institutional interest, perhaps the most remarkable development in recent years, has been the mainstream acceptance of UAP research by major institutions. NASA, traditionally focused on space exploration and scientific research, has established dedicated programs to study these phenomena. The Pentagon, through various offices and initiatives, has created formal reporting channels for military personnel to document UAP encounters without fear of ridicule or career consequences. This institutional involvement represents a fundamental shift. For decades, the topic was relegated to the fringes of serious discourse. Military pilots and commercial aviators who reported unusual sightings often faced skepticism or worse from their superiors. Scientists who expressed interest in studying such phenomena risked damage to their professional reputations. Today, the situation has changed dramatically. High-ranking military officials discuss UAPs in congressional hearings. NASA scientists appear on news programs to explain their research methodologies. The Pentagon releases previously classified videos and reports. This transformation from taboo subject to legitimate area of inquiry marks a new chapter in how we approach the unknown. Why UAPs matter today. The current interest in UAPs extends beyond simple curiosity about unusual sightings. Several practical considerations drive this renewed focus. National security implications. When unidentified objects appear in restricted airspace or near military installations, they represent potential security concerns. Understanding what these objects are, where they come from, and what capabilities they might possess becomes a matter of national defense. Aviation safety. Commercial and military pilots regularly encounter unexplained phenomena during flight operations. These encounters, whether they represent actual objects or sensor anomalies, can pose safety risks. Proper documentation and analysis help ensure flight safety for both military and civilian aviation. Scientific discovery. Some UAP reports describe flight characteristics that seem to challenge our current understanding of physics and engineering. If even a small percentage of these reports prove accurate, they could represent opportunities for significant scientific advancement. Public transparency. Decades of secrecy and official denial have created an environment of speculation and conspiracy theories. By approaching the topic openly and scientifically, institutions aim to provide the public with accurate information based on evidence rather than speculation. As we drift deeper into our exploration tonight, consider how this shift towards scientific inquiry represents humanity's eternal quest to understand the unknown. Whether UAPs ultimately prove to be advanced technology, natural phenomena we don't yet understand, or something else entirely, the process of investigation itself advances our knowledge and capabilities. Chapter 2. Origins and History of Official Investigations, the dawn of the modern UAP era. As you settle more comfortably into your evening rest, let us travel back to a pivotal moment in history. The year was 1947, and the world was still adjusting to the post-war reality. It was during this time that the modern era of UAP investigations truly began, triggered by events that would capture public imagination and government attention for decades to come. On June 24, 1947, private pilot Kenneth Arnold was flying his small aircraft near Mount Rainier in Washington state when he observed what he described as 9 unusual objects moving in formation at tremendous speed. Arnold, an experienced pilot and businessman, estimated their speed at over 1,200 miles per hour, far faster than any known aircraft of that era. When Arnold landed and shared his account with reporters, he described the object's movement as similar to saucers skipping across water. This casual description gave birth to the term flying saucers, which quickly entered popular vocabulary. Within weeks, similar reports began pouring in from across the United States and around the world. The sheer volume of reports, many coming from credible witnesses, including military personnel and experienced pilots, created a situation that government agencies could not ignore. What had begun as isolated incidents soon appeared to represent a pattern worthy of official investigation. Project Sign. The first systematic approach in early 1948, the United States Air Force established Project Sign, the first official military program dedicated to investigating what were then called flying saucers. Based at Wright-Patterson Air Force Base in Ohio, Project Sign represented the military's acknowledgement that these reports deserved serious attention. The project's investigators, many of whom were experienced military officers and engineers, approached their task with scientific methodology. They collected witness statements, analyzed photographs, examined physical evidence where available, and attempted to correlate sightings with known aircraft activities, weather conditions, and astronomical events. Project Sign's work revealed the complexity of the phenomenon they were investigating. Many cases had conventional explanations: weather balloons, aircraft lights seen under unusual conditions, astronomical objects, or natural phenomena. However, a significant number of reports remained unexplained even after thorough investigation. One of the most significant cases investigated by Project Sign occurred on January 7, 1948, near Fort Knox, Kentucky. Captain Thomas Mantell, an experienced P-51 Mustang pilot, was vectored to investigate an unidentified object reported by multiple witnesses, including the control tower at Godman Army Airfield. Mantell pursued the object to high altitude, radioing back descriptions of a large, metallic object before his final transmission. Shortly afterward, Mantell's aircraft crashed, killing the pilot. This incident, known as the Mantell Incident, became one of the most controversial cases in early UAP history and highlighted the potential dangers associated with pursuing unidentified objects. The evolution to Project Grudge. By late 1948, Project Sign had compiled hundreds of reports and conducted numerous investigations. The project's final report, completed in early 1949, concluded that while most sightings had conventional explanations, approximately 20% remained unexplained. Some investigators within the project believed these unexplained cases might represent technology of unknown origin. However, military leadership was uncomfortable with such conclusions. The Cold War was intensifying, and the idea that unknown, possibly foreign technology was operating with impunity over American territory was unsettling. In February 1949, Project Sign was redesignated as Project Grudge, with a mandate to approach the phenomenon more skeptically. Project Grudge operated under the assumption that all UAP reports could and should be explained through conventional means. Investigators were encouraged to find prosaic explanations for sightings, even when such explanations might not fully account for all observed details. The project's approach became notably more dismissive of witness testimony, particularly when witnesses were civilian rather than military. This shift in approach reflected broader institutional attitudes of the time. The military and intelligence communities were dealing with genuine threats from the Soviet Union, the development of nuclear weapons, and other pressing national security concerns. Unexplained aerial phenomena, while puzzling, were not seen as immediate threats requiring significant resources. The birth of Project Blue Book. Despite Project Grudge's skeptical approach, UAP reports continued to accumulate, and public interest in the phenomenon remained high. In 1952, several high-profile sightings, including radar contacts over Washington, D.C., brought renewed attention to the issue. The Air Force found itself under increasing pressure to provide satisfactory explanations for these incidents. In March 1952, Project Grudge was reorganized and renamed Project Blue Book. Under the leadership of Captain Edward Ruppelt, the project adopted a more balanced approach to investigation. Ruppelt, who later wrote one of the definitive accounts of early UAP investigations, believed that the phenomenon deserved serious scientific study, regardless of its ultimate explanation. Project Blue Book established more systematic procedures for investigating reports. The project created standardized forms for witness interviews, developed classification systems for different types of sightings, and began working with civilian scientists and researchers. This collaborative approach marked a significant improvement over the sometimes dismissive attitude of Project Grudge. The scope and scale of Blue Book investigations over its 22-year existence, Project Blue Book accumulated an impressive database of UAP reports. By the time of its closure in 1969, the project had investigated 12,618 reported sightings. This massive collection represented one of the most comprehensive attempts to document and analyze aerial anomalies in human history. The cases investigated by Blue Book ranged from simple misidentifications of conventional aircraft or natural phenomena to complex, multi-witness events involving radar confirmation and physical evidence. Some investigations were completed within days, while others extended over months or even years, as investigators attempted to correlate witness accounts with meteorological data, aircraft flight paths, and astronomical events. Project Blue Book's investigators developed considerable expertise in evaluating witness testimony, analyzing photographic evidence, and identifying the wide variety of natural and artificial phenomena that could be mistaken for unusual aerial objects. They became skilled at recognizing the effects of atmospheric conditions on visual observations, understanding how psychological factors could influence perception, and identifying the signatures of various types of military and civilian aircraft. Notable cases and investigations throughout its operation. Project Blue Book encountered several cases that became legendary in UAP literature. The Levelland, Texas incident of November 2, 1957, involved multiple witnesses reporting that their automobile engines and lights failed when approached by a luminous object. Blue Book investigators initially attributed the incident to ball lightning, though this explanation was controversial even within the project. The Exeter, New Hampshire incident of September 3, 1965, involved multiple police officers and civilians who observed a large, silent object with bright, pulsating lights. Despite extensive investigation, Blue Book was unable to provide a satisfactory conventional explanation for the sighting. Perhaps most famous was the Betty and Barney Hill case of 1961, which involved claims of alien abduction. While Blue Book did not officially investigate abduction claims, the case highlighted the cultural impact of UAP reports and the way they could evolve beyond simple sightings into more complex narratives. Scientific consultants and academic involvement. One of Project Blue Book's most significant contributions was its engagement with the civilian scientific community. The project worked with astronomers, physicists, meteorologists, and other specialists to better understand the various phenomena that might account for UAP reports. Dr. J. Allen Hynek, an astronomer at Northwestern University, served as Blue Book's primary scientific consultant for much of its existence. Initially skeptical of UAP reports, Hynek gradually became convinced that the phenomenon deserved serious scientific attention. His work with Blue Book led him to develop classification systems for UAP encounters that are still used today. Hynek's evolution from skeptic to serious researcher illustrates the complexity of the UAP phenomenon. As he gained experience investigating cases, he found that while many reports had conventional explanations, a significant minority defied easy categorization. His later work, after Blue Book's closure, helped establish UAP research as a legitimate field of scientific inquiry. The Condon Committee and external review by the mid-1960s, Project Blue Book faced increasing criticism from both believers and skeptics. Some felt the project was too dismissive of compelling cases, while others argued it gave unwarranted credibility to questionable reports. In response to this criticism, the Air Force commissioned the University of Colorado to conduct an independent scientific study of the UAP phenomenon. Led by physicist Dr. Edward Condon, this study became known as the Condon Committee or the Colorado Project. Operating from 1966 to 1968, The committee examined selected Blue Book cases and conducted its own investigations. The committee's work was controversial from the beginning, with some team members believing the study was designed to reach predetermined skeptical conclusions. The Condon Report, published in 1969, concluded that further study of UAPs was unlikely to yield scientific benefits. The report acknowledged that some cases remained unexplained, but argued that the unexplained cases did not constitute evidence of extraordinary phenomena. This conclusion provided the Air Force with the justification it sought to terminate Project Blue Book. The end of an era. On December 17, 1969, the Air Force announced the termination of Project Blue Book. The official statement declared that no UFO investigated and evaluated by the Air Force ever indicated a threat to national security, and that there was no evidence indicating that sightings categorized as unidentified were extraterrestrial vehicles. The closure of Blue Book marked the end of the first era of official UAP investigation. For the next several decades, government interest in the phenomenon would be minimal and largely covert. The public perception that official investigation had ended would persist until the dramatic developments of the 21st century. However, Project Blue Book's legacy extended far beyond its official conclusions. The project had demonstrated that UAP reports could be investigated systematically and scientifically. It had shown that, while many reports had conventional explanations, a significant percentage remained genuinely unexplained even after thorough investigation. Most importantly, it had established procedures and methodologies that would prove valuable when official interest in UAPs eventually resumed. As we prepare to explore the modern renaissance of UAP investigation, it's worth reflecting on the groundwork laid by these early programs. The investigators of Projects Sign, Grudge, and Blue Book worked with limited technology and under significant institutional pressure. Yet their careful documentation and methodical approach created a foundation that modern researchers continue to build upon. Chapter 3. Resurgence of the topic in the modern era. The quiet years. As you continue your peaceful journey towards sleep, let us now traverse the decades that followed Project Blue Book's closure. From 1969 through the early 2000s, official government interest in UAPs seemed to disappear entirely. The topic retreated from mainstream discourse, relegated once again to the realm of amateur investigators, documentaries, and popular culture. During these quiet decades, however, reports continued to accumulate. Commercial airline pilots, military personnel, air traffic controllers, and civilian observers still encountered unexplained aerial phenomena. Without official channels for reporting or investigation, many of these incidents went undocumented or were shared only in informal networks. The lack of official attention didn't mean the phenomenon had disappeared. Rather, it meant that the systematic collection and analysis of data had ceased. Individual cases might receive local media attention or be investigated by civilian researchers, but the comprehensive, government-sponsored approach of the Blue Book era was gone. This period of official silence would eventually prove unsustainable as technology advanced and the quality of evidence improved. High-resolution cameras, sophisticated radar systems, and other detection equipment began capturing UAP encounters with unprecedented clarity and detail. The catalyst: military encounters of the 21st century. The modern renaissance of UAP investigation can be traced to a series of encounters involving United States Navy personnel in the early 2000s. These incidents, which would not become widely known until years later, represented a new category of UAP encounter: cases involving multiple sensors, multiple trained observers, and high-quality documentation. The first of these pivotal encounters occurred in November 2004, during training exercises off the coast of San Diego. The USS Princeton, an Aegis-class cruiser equipped with advanced radar systems, began tracking unusual objects operating in the area. These objects appeared to move in ways that defied conventional understanding of aerodynamics and propulsion. On November 14, 2004, two F/A-18 Super Hornet fighters from the USS Nimitz were diverted to investigate one of these radar contacts. The mission, initially routine, would produce some of the most compelling UAP evidence in modern history. Commander David Fravor and Lieutenant Commander Jim Slate, both experienced naval aviators, encountered an object unlike anything in their extensive flying experience. The object appeared as a white, oval-shaped craft approximately 40 feet in length. It demonstrated flight characteristics that seemed impossible for known technology: instantaneous acceleration, the ability to stop and hover motionlessly, and movement patterns that showed no respect for the limitations of conventional propulsion or aerodynamics. The Tic Tac incident, Commander Fravor's encounter with what became known as the Tic Tac object, lasted several minutes and was witnessed by multiple naval personnel. The object appeared to respond to the presence of the Navy fighters, moving in ways that suggested awareness of their approach. When Fravor attempted to intercept the object, it accelerated away at speeds that defied explanation. What made this encounter particularly significant was the quality and quantity of documentation. The incident was tracked on multiple radar systems, witnessed by experienced military personnel, and later investigated by intelligence specialists. The combination of multiple sensors, trained observers, and official documentation created a case that was difficult to dismiss or explain through conventional means. Following the encounter, a second pair of Navy fighters was directed to the area. These aircraft were equipped with advanced targeting systems that successfully tracked and filmed an unidentified object. This footage, known as the FLIR-1 video, would later become one of the most analyzed pieces of UAP evidence in history. The FLIR-1 video, captured through the aircraft's forward-looking infrared system, shows an object displaying unusual flight characteristics. The pilots can be heard expressing confusion and amazement at what they are observing. Their professional commentary provides context for the visual evidence, creating a compelling document of an unexplained encounter. Additional naval encounters. The 2004 Nimitz incident was not an isolated event. In 2014 and 2015, Navy personnel aboard the USS Theodore Roosevelt encountered similar phenomena during training exercises off the east coast of the United States. These encounters produced additional video evidence, including footage known as gimbal and go fast. The gimbal video, captured in January 2015, shows an object that appears to rotate while maintaining its position relative to the observing aircraft. The object's thermal signature and movement patterns puzzled military analysts and intelligence personnel. Like the earlier Nimitz incident, this encounter involved multiple witnesses and sensor systems. The Go Fast video, also from 2015, shows an object moving rapidly over the ocean surface. While some analysts have suggested the object might be a conventional aircraft or drone seen under unusual conditions, others point to aspects of its movement that seem inconsistent with known technology. These encounters shared several characteristics that made them particularly compelling. They involved highly trained military observers, multiple sensor systems, and occurred during official military operations. The witnesses were experienced professionals whose careers depended on accurate observation and reporting. The incidents were documented through official channels and investigated by intelligence specialists. The Pentagon's historic disclosure for over a decade, these remarkable encounters remained classified, known only to a small number of military and intelligence personnel. However, in 2020, the Pentagon took an unprecedented step that would transform public understanding of UAPs forever. On April 27, 2020, the Department of Defense officially released 3 videos showing unidentified aerial phenomena. These were the same FLIR 1, gimbal, and go fast videos that had been leaked to the media in previous years, but now they carried the full weight of official acknowledgement. The Pentagon statement accompanying the release was carefully worded but historically significant. The Department of Defense is releasing the videos in order to clear up any misconceptions by the public on whether or not the footage that has been circulating was real, or whether or not there is more to the videos. The aerial phenomena observed in the videos remain characterized as unidentified. This release represented a fundamental shift in official policy. For the first time in decades, the U.S. government was publicly acknowledging that its military forces had encountered aerial phenomena that could not be explained through conventional means. The implications of this acknowledgement would ripple through scientific, media, and policy communities worldwide. Congressional interest and mandated reports. The Pentagon's video release catalyzed interest among members of Congress, who began asking questions about UAPs and the government's knowledge of such incidents. This legislative interest led to formal requirements for government agencies to report on UAP encounters and investigations. In December 2020, the Intelligence Authorization Act for fiscal year 2021 included a provision requiring the Director of National Intelligence to submit an unclassified report on UAPs within 180 days. This mandate, supported by both Republican and Democratic lawmakers, demonstrated bipartisan interest in understanding the phenomenon. The resulting report, titled Preliminary Assessment, Unidentified Aerial Phenomena, was delivered to Congress in June 2021. While the unclassified version was brief and limited in detail, it represented another historic milestone in official UAP disclosure. The report acknowledged 144 instances of UAP encounters by government personnel since 2004, with only one case receiving a definitive identification. The document stated that UAPs clearly pose a safety of flight issue and may pose a challenge to U.S. national security. The creation of RO congressional interest in UAPs continued to grow, leading to the establishment of a new government office specifically dedicated to investigating aerial anomalies. In July 2022, the Department of Defense announced the creation of the All-Domain Anomaly Resolution Office, known as RO. RO represents the most comprehensive official UAP investigation program since Project Blue Book. Unlike its predecessor, RO operates with modern technology, scientific methodologies, and explicit support from senior government officials. The office coordinates UAP investigations across all branches of the military and intelligence community. The creation of RO signaled that the government's approach to UAPs had evolved from sporadic investigation to systematic, ongoing research. The office was tasked with collecting reports from military personnel, analyzing data from multiple sensor systems, and providing regular updates to Congress and the public. Dr. Sean Kirkpatrick, a physicist and intelligence official, was appointed as RO First Director. Under his leadership, the office began developing standardized procedures for UAP reporting and investigation. Military personnel were encouraged to report encounters without fear of professional consequences, addressing one of the long-standing barriers to comprehensive data collection. NASA entry into UAP research, perhaps the most significant development in the modern UAP era, has been NASA's formal entry into the field. In June 2022, NASA announced the formation of an independent study team to examine UAPs from a scientific perspective. This announcement marked the first time the space agency had officially acknowledged interest in studying the phenomenon. NASA's approach to UAP research emphasizes scientific methodology and data analysis. The agency's study team includes experts in various fields: atmospheric physics, aerospace engineering, data analysis, and astrobiology. Their mandate is to identify the data needed to advance scientific understanding of UAPs and recommend how NASA might contribute to the overall government effort. The space agency's involvement brings several advantages to UAP research. NASA has extensive experience with aerial and space-based observation systems, sophisticated data analysis capabilities, and a culture of scientific rigor. The agency's participation helps legitimize UAP research within the broader scientific community. Dr. Thomas Zurbuchen, NASA Associate Administrator for Science, emphasized the agency's commitment to transparency and scientific methodology. NASA believes that the tools of scientific discovery are powerful and apply here also. We have access to a broad range of observations of Earth and our solar system, and it is our responsibility to see if we can apply them to this topic as well. The transformation of public discourse, the official acknowledgement of UAPs by government agencies, has fundamentally altered public discourse on the topic. What was once confined to the margins of mainstream discussion is now the subject of congressional hearings, scientific conferences, and news reports from major media outlets. This transformation has several important implications. First, it has encouraged more witnesses to come forward with their accounts, knowing they will be taken seriously by official investigators. Military personnel, in particular, have begun reporting encounters that they previously might have kept private due to career concerns. Second, the official acknowledgement has attracted serious scientific interest. Researchers who might have avoided UAP studies due to professional concerns are now participating in investigations and analysis. This influx of scientific expertise promises to improve the quality of UAP research significantly. Third, the mainstream acceptance of UAP research has led to improved funding and resources for investigation. Government agencies are allocating budgets specifically for UAP research, and private organizations are supporting scientific studies of the phenomenon. Ongoing mysteries and future investigations. As we near the end of our first evening's journey through the world of official UAP investigation, it's important to acknowledge that many questions remain unanswered. Despite decades of investigation and the recent surge in official interest, the nature and origin of UAPs remain mysterious. Some of the most compelling cases from both the historical record and recent encounters continue to defy conventional explanation. The objects observed by military personnel demonstrate flight characteristics that challenge our understanding of physics and engineering. They appear to operate without visible propulsion systems, accelerate at rates that would be lethal to human occupants, and maneuver in ways that seem impossible for known technology. The ongoing investigations by ARRO, NASA, and other agencies are applying the most advanced analytical tools available to understand these phenomena. They are examining data from multiple sensor systems, correlating observations with atmospheric conditions, and exploring potential explanations ranging from foreign technology to natural phenomena we don't yet understand. Reflections on a remarkable journey. As we conclude this first part of our documentary journey, take a moment to reflect on the remarkable transformation we've witnessed. From the early days of Project Sign through the modern era of ARRO and NASA scientific panels, the approach to UAP investigation has evolved dramatically. What began as ad hoc responses to unusual sightings has become a sophisticated, multi-agency effort involving some of the world's most advanced detection and analysis systems. The stigma that once surrounded UAP reports has been replaced by official encouragement for witnesses to come forward. The dismissive attitudes of earlier eras have given way to genuine scientific curiosity and methodical investigation. This transformation reflects humanity's growing technological capabilities and our evolving understanding of scientific methodology. Today's investigators have tools and techniques that the Project Blue Book team could never have imagined. They can analyze radar data with unprecedented precision, enhance photographic evidence using advanced algorithms, and correlate multiple sensor inputs to build comprehensive pictures of UAP encounters. Yet for all our technological advancement, the fundamental mystery remains. UAPs continue to be reported, documented, and investigated. Each new case adds to our understanding, while simultaneously raising new questions. The phenomenon that captured public attention in 1947 continues to challenge our assumptions about technology, physics, and our place in the universe. The cultural impact of official acknowledgement as we continue our gentle journey through the night. Let us pause to consider how the official acknowledgement of UAPs has transformed not just government policy, but the broader cultural landscape surrounding these phenomena. For decades, the topic existed in a peculiar limbo, widely known in popular culture, yet officially dismissed or ignored by institutions. The Pentagon's 2020 video release created ripple effects that extended far beyond government circles. News organizations that had previously relegated UAP stories to entertainment sections began treating them as legitimate news. Scientific journals that had once avoided the topic started publishing papers on aerial anomaly analysis. Academic conferences began including sessions on UAP research methodologies. This cultural shift represents more than changing attitudes toward a single topic. It reflects an evolution in how institutions approach the unknown and acknowledge the limits of current knowledge. The willingness to say we don't know, but we're investigating marks a mature approach to scientific inquiry that had been notably absent from official UAP discourse for decades. The transformation has also affected the individuals who report UAP encounters. Military personnel who had remained silent about unusual sightings for years began coming forward, knowing they would face investigation rather than ridicule. Commercial pilots started filing reports through official channels instead of keeping their experiences private. Air traffic controllers began documenting unusual radar contacts rather than dismissing them as equipment malfunctions. The evolution of investigative technology, modern UAP investigations, benefit from technological capabilities that were unimaginable during the Project Blue Book era. Today's military aircraft carry sophisticated sensor packages that can simultaneously track objects visually, thermally, and through radar. These multispectral detection systems provide investigators with far more comprehensive data than was available to earlier researchers. Contemporary radar systems operate with precision and sensitivity that dwarf their predecessors. Modern installations can track objects moving at various altitudes and speeds, providing detailed trajectory information and velocity measurements. When multiple radar sites track the same object, investigators can triangulate positions with remarkable accuracy and create three-dimensional models of object movement. Thermal imaging technology has advanced dramatically since the early days of FLIR systems. Modern infrared sensors can detect minute temperature differences and track heat signatures through various atmospheric conditions. This capability proves particularly valuable when investigating objects that might not reflect radar signals or remain visible to conventional cameras. Digital photography and video recording have revolutionized evidence collection and analysis. High-resolution cameras can capture details that would have been impossible to document with earlier film-based systems. Digital files can be analyzed using sophisticated software that can enhance images, measure object dimensions, and track movement patterns frame by frame. Perhaps most importantly, modern computer systems can store, correlate, and analyze vast amounts of data from multiple sources simultaneously. Investigators can cross-reference radar tracks with pilot observations, correlate sightings with weather data, and compare new cases with historical records in ways that would have required months of manual work in earlier eras. The psychology of witness testimony, one aspect of UAP investigation that has received increased attention in recent years, is the psychology of witness testimony. Modern investigators understand that even highly trained, reliable witnesses can be influenced by various factors that affect perception and memory. This understanding has led to more sophisticated approaches to collecting and evaluating witness accounts. Research in cognitive psychology has revealed how stress, expectation, and environmental factors can influence what people observe and remember. Military pilots operating at high speeds and altitudes face unique perceptual challenges that can affect their interpretation of visual stimuli. Understanding these factors doesn't diminish the value of witness testimony, but rather helps investigators interpret it more accurately. Modern investigative protocols account for these psychological factors by using structured interview techniques designed to minimize leading questions and recover the most accurate possible recollection of events. Investigators are trained to recognize the difference between what witnesses actually observed and their interpretations of those observations. The use of multiple witnesses has become a crucial element in evaluating UAP encounters. When several independent observers report similar phenomena, it reduces the likelihood that the sighting results from individual perceptual errors or psychological factors. The most compelling modern cases typically involve multiple witnesses using multiple sensor systems, creating a web of corroborating evidence that is difficult to dismiss. International perspectives and cooperation. While this documentary focuses primarily on United States government investigations, it's important to recognize that UAP encounters and official investigations occur worldwide. Many countries have established their own investigation programs or have released previously classified UAP files to the public. The United Kingdom's Ministry of Defense operated UAP investigation programs for decades, accumulating thousands of reports before closing its official investigation unit in 2009. In 2020, the UK began releasing previously classified UAP files, revealing decades of encounters reported by military personnel and civilian witnesses. France has taken perhaps the most scientifically rigorous approach to UAP investigation through its JPAN program, operated by the French space agency CNES. JPAN applies scientific methodology to UAP reports and publishes detailed case studies, including cases that remain unexplained after thorough investigation. Other nations, including Belgium, Chile, and Brazil, have established official UAP investigation programs or have released government files related to aerial anomalies. This international dimension suggests that whatever UAPs represent, they constitute a global rather than regional phenomenon. The increasing openness of various governments has created opportunities for international cooperation in UAP research. Scientists and investigators from different countries can now share data, compare methodologies, and collaborate on analysis of particularly compelling cases. This international approach promises to accelerate progress in understanding these phenomena. The scientific method applied to UAP's modern UAP investigation represents an attempt to apply rigorous scientific methodology to a phenomenon that has historically been associated with speculation and pseudoscience. This scientific approach requires careful hypothesis formation, systematic data collection, objective analysis, and peer review of conclusions. The first step in scientific UAP investigation involves clearly defining what constitutes a UAP encounter. Modern investigators use specific criteria to distinguish between sightings that warrant detailed investigation and those that can be readily explained through conventional means. This triage process ensures that limited investigative resources focus on the most promising cases. Data collection follows established scientific protocols designed to minimize bias and maximize accuracy. Investigators document environmental conditions, record all available sensor data, conduct structured interviews with witnesses, and collect any physical evidence. This comprehensive approach creates detailed case files that can be analyzed using various methodologies. Analysis of UAP data employs techniques borrowed from various scientific disciplines. Physicists analyze flight characteristics and energy requirements. Meteorologists evaluate atmospheric conditions that might influence observations. Psychologists assess witness reliability and perceptual factors. Engineers examine recorded data for signatures of known technology. The peer review process, fundamental to scientific research, is gradually being applied to UAP studies. Research papers on UAP-related topics are beginning to appear in mainstream scientific journals, where they undergo the same scrutiny as any other scientific work. This development represents a crucial step toward establishing UAP research as a legitimate scientific discipline. The challenge of physical evidence, one of the most significant challenges in UAP research, is the general lack of physical evidence. Unlike many other scientific phenomena, UAPs rarely leave behind material traces that can be analyzed in laboratory settings. This absence of physical evidence has historically made it difficult to apply traditional scientific methods to UAP investigation. However, modern technology is beginning to address this challenge. Advanced sensor systems can detect and record various types of evidence that might not be apparent to human observers. Electromagnetic signatures, atmospheric disturbances, and thermal anomalies can all provide indirect physical evidence of unusual phenomena. Some UAP encounters have produced measurable environmental effects. Cases involving alleged electromagnetic interference with aircraft systems or ground-based equipment create opportunities for scientific analysis. When such effects can be documented and verified, they provide valuable data for understanding the nature of UAP phenomena. The search for physical evidence has also led to innovative approaches to data collection. Some researchers have proposed networks of automated monitoring stations equipped with various sensors, designed to detect and record unusual aerial activity continuously. While such systems remain largely theoretical, they represent the kind of systematic approach that might eventually yield conclusive physical evidence. Theoretical frameworks and hypotheses, scientific investigation of UAPs, requires consideration of various theoretical frameworks that might explain the observed phenomena. These hypotheses range from conventional explanations involving known technology or natural phenomena to more exotic possibilities that would require significant revisions to current scientific understanding. Conventional explanations for UAP encounters include misidentification of known aircraft, atmospheric phenomena, astronomical objects, or equipment malfunctions. Modern investigators carefully evaluate each case against these possibilities before classifying encounters as unexplained. Many reported UAPs do, indeed, fall into these conventional categories when subjected to thorough analysis. More exotic conventional explanations involve classified military technology, experimental aircraft, or foreign government capabilities. The rapid advancement of drone technology, in particular, has created new possibilities for aerial vehicles with unusual flight characteristics. Some UAP encounters might represent observations of classified military programs or foreign technology demonstrations. Natural phenomena represent another category of potential explanations. Atmospheric effects, unusual weather conditions, or rare astronomical events might account for some UAP sightings. Ball lightning, plasma phenomena, and other poorly understood natural processes could potentially explain encounters that seem to defy conventional explanation. The most exotic theoretical frameworks involve possibilities that would challenge current scientific understanding. These might include advanced propulsion technologies based on principles not yet understood by mainstream science, or phenomena related to theoretical physics concepts, such as exotic matter or spacetime manipulation. While these exotic explanations remain highly speculative, scientific methodology requires their consideration alongside more conventional possibilities. The goal is not to prove or disprove any particular explanation, but rather to evaluate all possibilities objectively based on available evidence. The role of artificial intelligence in UAP analysis. Modern UAP investigation increasingly relies on artificial intelligence and machine learning technologies to analyze large quantities of data and identify patterns that might not be apparent to human investigators. These technologies offer several advantages in processing the complex, multi-source data typical of UAP encounters. Pattern recognition algorithms can analyze video footage to identify objects exhibiting unusual flight characteristics. These systems can track movement patterns, measure velocities and accelerations, and flag sequences that deviate significantly from normal aircraft behavior. Such automated analysis can process hours of video footage in minutes, identifying potential UAP encounters that might otherwise be overlooked. Machine learning systems can correlate data from multiple sources to identify relationships that might not be obvious to human analysts. For example, AI systems might identify correlations between UAP sightings and atmospheric conditions, electromagnetic disturbances, or other environmental factors. Such correlations could provide insights into the nature of UAP phenomena or help predict when encounters are most likely to occur. Natural language processing technologies can analyze witness reports and historical case files to identify common elements or patterns in UAP encounters. These systems can process thousands of reports to identify recurring themes, locations, or characteristics that might provide clues about the nature of these phenomena. However, AI analysis also presents challenges for UAP research. Machine learning systems are only as good as the data they're trained on, and they can perpetuate biases present in historical records. The interpretation of AI analysis results requires human expertise to distinguish between genuine patterns and statistical artifacts. Public disclosure and information management. The modern era of UAP investigation has raised important questions about public disclosure and information management. Government agencies must balance the public's right to know with legitimate national security concerns, operational security requirements, and the need to protect ongoing investigations. The decision to release the 3 Navy videos in 2020 represented a significant shift toward greater transparency in UAP matters. However, many questions remain about what information should be made public and when. Some argue for complete transparency, while others contend that certain types of information should remain classified to protect intelligence sources and methods. The challenge of public disclosure is complicated by the nature of UAP phenomena themselves. Unlike conventional military or intelligence topics, UAPs capture public imagination in ways that can lead to speculation, conspiracy theories, and misinterpretation of official statements. Government agencies must consider how their communications about UAPs will be received and potentially misunderstood by various audiences. Modern information management approaches attempt to provide meaningful transparency while protecting sensitive information. This might involve releasing sanitized versions of reports, providing statistical summaries of UAP encounters, or sharing general methodologies without revealing specific technical capabilities. The goal of these disclosure policies is to maintain public trust while ensuring that UAP investigations can continue effectively. This balance requires ongoing evaluation and adjustment as new cases arise and public expectations evolve. The future of UAP research as we approach the final moments of our first evening's exploration. It's worth considering what the future might hold for UAP research and investigation. The current era of official acknowledgement and scientific inquiry is still in its early stages, with many developments likely in the years ahead. Technological advancement will undoubtedly play a major role in future UAP research. Improved sensor systems, more sophisticated analysis tools, and enhanced data collection capabilities will provide investigators with better evidence and more comprehensive understanding of UAP phenomena. The deployment of artificial intelligence and machine learning technologies will accelerate the analysis of large datasets and help identify patterns that might otherwise remain hidden. International cooperation in UAP research is likely to expand as more governments acknowledge the phenomenon and share their data and methodologies. This global approach could lead to more comprehensive understanding and might reveal whether UAP characteristics vary by geographic region or remain consistent worldwide. Scientific acceptance of UAP research as a legitimate field of inquiry will probably continue to grow as more researchers become involved and more data becomes available for analysis. The establishment of peer-reviewed publication channels and academic research programs could accelerate progress significantly. However, future UAP research will also face ongoing challenges. The phenomenon's elusive nature makes it difficult to study using traditional scientific methods. The interdisciplinary nature of UAP investigation requires expertise from multiple fields, which can complicate research coordination and funding. Perhaps most importantly, future UAP research will need to maintain scientific rigor while remaining open to possibilities that might challenge current understanding. This balance between skepticism and openness represents one of the greatest challenges in the field. Tomorrow's mysteries, as you prepare for sleep, your mind filled with these fascinating accounts of official investigation and scientific inquiry. Remember that the story of UAP research continues to unfold. Each day brings new reports, new analyses, and new insights into these enduring mysteries. The transformation from ridicule to serious scientific inquiry represents more than just changing attitudes toward UAPs. It reflects humanity's evolving approach to the unknown and our growing sophistication in applying scientific methodology to puzzling phenomena. Whether UAPs ultimately prove to represent advanced technology, natural phenomena we don't yet understand, or something else entirely, The process of investigation itself advances our knowledge and capabilities. In our next segment, we will explore the specific encounters that have shaped modern UAP research, examining the detailed accounts of military personnel, the analysis of sensor data, and the ongoing efforts to understand what these phenomena represent. We'll delve into the technical aspects of UAP investigation and the various theories proposed to explain these remarkable encounters. For now, rest well, knowing that somewhere in the vast expanse of our atmosphere and beyond, mysteries await discovery. The dedicated investigators of ARRO, NASA, and other agencies continue their careful work, applying the tools of science to phenomena that have puzzled humanity for decades. The journey toward understanding continues, one careful observation, one thorough analysis, one documented case at a time. In this systematic pursuit of knowledge, we see humanity at its best, curious, persistent, and committed to understanding the unknown through evidence and reason rather than assumption and speculation. Sweet dreams, and may your rest be filled with wonder at the mysteries that surround us, and appreciation for those who dedicate their lives to understanding them. Tomorrow, we will continue our exploration of these remarkable phenomena and the dedicated individuals working to unravel their secrets. Part 2. Modern Evidence and Scientific Analysis, Contemporary Investigations and Congressional Testimony Transition. From history to present, welcome back to our peaceful exploration of unidentified aerial phenomena. As you settle into this second hour of our journey, we transition from the historical foundations we explored earlier to the remarkable developments unfolding in our current era. The night sky above us remains the same canvas that has captured human imagination for millennia, yet our ability to observe, document, and analyze what occurs within it has evolved dramatically. Tonight, we will examine the most recent official reports, hear the compelling testimonies of military personnel speaking under oath before Congress, and explore how the scientific community is approaching these enduring mysteries with unprecedented rigor and transparency. As you relax into this continuing narrative, let your mind drift through these carefully documented accounts of our ongoing quest to understand the unknown. The transformation we witnessed in Part 1, from dismissal to serious investigation, has accelerated remarkably in recent years. Government agencies that once avoided the topic now produce detailed annual reports. Military personnel who once remained silent now testify before Congress. Scientists who once avoided the subject now propose systematic research programs. This evolution represents one of the most significant shifts in institutional attitude toward unexplained phenomena in modern history. Chapter 4. Recent official reports on UAPs, the dawn of systematic reporting as the gentle rhythm of night settles around us. Let us explore the most comprehensive official examination of UAP encounters ever undertaken. In the quiet hours when most of the world sleeps, dedicated analysts and investigators continue their methodical work, processing reports, analyzing data, and building our understanding of these persistent mysteries one case at a time. The year 2023 marked a watershed moment in official UAP reporting. For the first time since Project Blue Book, government agencies began producing regular, comprehensive reports on UAP encounters, complete with statistical analysis, categorization of sightings, and frank acknowledgement of what remains unexplained. These reports represent a level of transparency and systematic approach that would have been unimaginable just a few years earlier. The most significant of these documents emerged from the collaboration between the Office of the Director of National Intelligence and the Department of Defense. This consolidated report, released in 2023, represented the most thorough official analysis of UAP data in decades, examining encounters reported between May 2023 and June 2024. The scope and detail of this analysis marked a new era in government transparency regarding aerial anomalies. A comprehensive database, the 2023 Consolidated Report, examined an impressive total of 757 recent UAP cases, representing a significant increase in reporting compared to previous years. This substantial number reflects several important developments: improved reporting procedures that encourage personnel to document encounters, better data collection systems that capture more incidents, and increased awareness among military and civilian observers about the importance of documenting unusual aerial phenomena. The sheer volume of cases analyzed demonstrates the persistent nature of UAP encounters. These are not isolated incidents occurring occasionally, but rather a continuous stream of reports from trained observers across military and civilian aviation. The consistency of reporting suggests that whatever UAPs represent, they constitute an ongoing phenomenon deserving of serious attention and systematic study. The geographic distribution of these cases spans the globe, with reports originating from various military installations, civilian airports, and training areas. This worldwide pattern indicates that UAP encounters are not confined to specific regions or types of airspace, but rather represent a global phenomenon that affects aviation operations across different environments and conditions. The temporal distribution of reports also reveals interesting patterns. Some periods show increased activity, while others demonstrate relatively quiet intervals. Investigators are working to determine whether these variations reflect actual changes in UAP activity, differences in reporting rates, or other factors that might influence the documentation of encounters. The process of investigation and analysis. Each of the 757 cases underwent a systematic investigation process designed to determine whether conventional explanations could account for the reported phenomena. This process represents a significant advancement over earlier investigation methods, employing modern analytical tools and standardized procedures to ensure consistency and thoroughness in case evaluation. The investigation process begins with a careful review of all available data, witness statements, radar tracks, photographic or video evidence, and environmental conditions at the time of the sighting. Investigators examine weather patterns, aircraft traffic, astronomical events, and other factors that might explain the observed phenomena. This comprehensive approach ensures that conventional explanations are thoroughly explored before cases are classified as unexplained. Advanced computer systems assist in this analysis, correlating multiple data sources and identifying patterns that might not be apparent to human investigators. Sophisticated algorithms can match sighting reports with known aircraft flight paths, satellite passes, meteorological events, and astronomical phenomena. This technological assistance allows investigators to process large volumes of data efficiently while maintaining analytical rigor. The standardization of investigation procedures ensures that all cases receive consistent evaluation regardless of who conducts the investigation or where the incident occurred. This consistency is crucial for building a reliable database that can support meaningful statistical analysis and pattern recognition. Conventional explanations. The mundane reality, the systematic analysis of the 757 cases revealed that a significant portion, nearly 300 incidents, could be explained through conventional means. This finding underscores the importance of thorough investigation and the value of applying scientific methodology to UAP reports. Far from diminishing the significance of UAP research, these explained cases actually strengthen confidence in the investigation process and highlight the credibility of cases that remain unexplained. Weather balloons emerged as one of the most common explanations for UAP reports. These scientific instruments, released regularly by meteorological services worldwide, can appear unusual when observed under certain lighting conditions or atmospheric circumstances. High-altitude balloons, in particular, can exhibit apparently anomalous movement patterns when influenced by jet streams and other atmospheric phenomena. Wildlife, particularly birds flying in formation or individual large birds observed at distance, accounted for another significant category of explained sightings. Migrating waterfowl, soaring raptors, and even individual birds illuminated by unusual lighting conditions can create compelling visual effects that might seem anomalous to observers unfamiliar with avian behavior and appearance. The rapid expansion of drone technology has created an entirely new category of aerial objects that can appear unusual to unfamiliar observers. Commercial drones, military unmanned vehicles, and experimental aircraft can exhibit flight characteristics that differ significantly from traditional aircraft, potentially leading to UAP reports when observed by personnel not familiar with these emerging technologies. Perhaps most interestingly, the proliferation of satellite constellations, particularly SpaceX's Starlink satellites, has created a new source of unusual aerial observations. These satellites, often visible as chains of moving lights during deployment or when reflecting sunlight under specific conditions, have generated numerous UAP reports from observers unfamiliar with their appearance and behavior. The significance of Starlink and modern satellites, the impact of modern satellite technology on UAP reporting deserves special attention, as it illustrates how technological advancement can create new categories of aerial phenomena that might initially appear anomalous. The Starlink constellation, consisting of thousands of small satellites designed to provide global internet coverage, represents the largest deployment of artificial objects in Earth orbit in human history. When Starlink satellites are first deployed, they often travel in close formation, creating the appearance of a train of lights moving across the sky. To observers unfamiliar with satellite deployment procedures, this sight can appear highly unusual and potentially anomalous. The satellite's movement patterns, brightness variations, and formation behavior can create compelling visual displays that might reasonably be reported as UAP encounters. Traditional satellites have also contributed to UAP reports throughout the space age, but the dramatic increase in satellite deployments in recent years has amplified this effect. Geostationary satellites, polar orbiting weather satellites, and various military and scientific spacecraft all contribute to the population of artificial objects that can appear unusual under specific observational conditions. The challenge for UAP investigator is distinguishing between known satellite activity and genuinely anomalous phenomena. This requires access to comprehensive databases of satellite positions and characteristics, sophisticated tracking systems, and expertise in orbital mechanics. The development of these analytical capabilities represents a significant advancement in UAP investigation methodology. Cases requiring further investigation, while nearly 300 of the 757 cases received conventional explanations, hundreds of others remain unresolved, though not necessarily because they represent anomalous phenomena. Many of these cases simply lack sufficient information for definitive analysis, highlighting the ongoing challenges in UAP investigation and the importance of improving data collection procedures. Some reports consist of brief visual observations without supporting sensor data, photographic evidence, or multiple witnesses. These cases, while potentially representing genuine anomalous encounters, cannot be definitively categorized without additional information. The limitation illustrates the importance of systematic data collection and the value of multiple independent observations. Environmental factors also complicate the analysis of some cases. Atmospheric conditions can significantly affect the appearance of conventional objects, creating visual effects that might seem anomalous. Investigating such cases requires detailed meteorological data and sophisticated understanding of atmospheric optics, resources that may not always be available for historical cases. Equipment malfunctions and calibration issues can also create apparent anomalies in sensor data that require extensive technical analysis to identify and correct. Modern investigation procedures include careful examination of equipment status and calibration records, but this information may not be available for all historical cases. The temporal gap between observation and reporting can also affect case analysis. Memory can be influenced by various factors, and details may become less reliable over time. The most valuable cases for investigation are those reported promptly, with immediate documentation of conditions and observations. The emphasis on scientific rigor throughout the 2023 Consolidated Report. Investigators emphasized their commitment to scientific methodology and evidence-based analysis. The report explicitly states that to date, RO has found no evidence of extraterrestrial life, activity, or technology in any investigated cases. This statement reflects not a predetermined skeptical bias, but rather the results of systematic analysis using established scientific criteria. This emphasis on evidence-based conclusions represents a significant departure from earlier approaches to UAP investigation. Rather than beginning with assumptions about what UAPs might represent, modern investigators focus on what the available evidence actually supports. This methodology ensures that conclusions remain grounded in demonstrable facts, rather than speculation or preconceived notions. The scientific approach also requires acknowledgement of uncertainty when evidence is insufficient for definitive conclusions. Rather than forcing cases into predetermined categories, investigators maintain classifications that accurately reflect the state of available evidence. This honest approach to uncertainty builds credibility and ensures that future evidence can be properly incorporated into ongoing analysis. The commitment to scientific rigor extends to the public presentation of findings. Reports avoid sensational language and focus on factual descriptions of observations and analytical results. This measured approach helps maintain public confidence in the investigation process, while avoiding the speculation that has historically surrounded UAP research. Safety and risk assessment. An important aspect of the recent official reports is their focus on aviation safety and risk assessment, rather than speculation about UAP origins. The primary concern of investigator is determining whether UAP encounters pose risks to aircraft operations, military security, or civilian safety. This practical focus helps ensure that UAP research contributes to tangible safety improvements, regardless of what UAPs ultimately prove to represent. The 2023 report noted that no investigated incidents caused harm to aircraft or personnel, a finding that helps contextualize the nature of UAP encounters. While these phenomena clearly warrant investigation and monitoring, they do not appear to represent immediate threats to aviation safety based on current evidence. However, the potential for risk remains a legitimate concern. Unidentified objects operating in controlled airspace could pose collision hazards, and unusual phenomena could potentially affect aircraft systems or pilot performance. Ongoing monitoring and investigation help ensure that any emerging risks are identified and addressed promptly. The risk assessment approach also considers the potential for UAP encounters to affect military operations or reveal vulnerabilities in detection and response systems. Understanding how unidentified phenomena interact with military assets helps improve overall security and operational effectiveness. Statistical patterns and trends. The large sample size of 757 cases allows for meaningful statistical analysis of UAP encounter patterns. Investigators have begun identifying trends in reporting frequency, geographic distribution, and encounter characteristics that may provide insights into the nature of these phenomena. Temporal patterns in UAP reporting show interesting variations that may correlate with factors such as military exercise schedules, seasonal weather patterns, or astronomical events. Understanding these correlations helps investigators distinguish between actual phenomena and factors that influence reporting rates or observation conditions. Geographic analysis reveals clustering of reports around certain military installations and training areas, which might reflect increased observation capabilities and reporting protocols in these locations, rather than higher actual UAP activity. Alternatively, such clustering might indicate that UAPs are attracted to or associated with specific types of activities or locations. The characteristics of reported UAPs also show statistical patterns that may provide clues about their nature. Size distributions, movement patterns, and duration of encounters all show measurable trends that can be analyzed for consistency with various theoretical explanations. These statistical approaches represent a significant advancement in UAP research methodology. By treating large collections of cases as datasets amenable to quantitative analysis, investigators can identify patterns that might not be apparent when examining individual cases in isolation. International coordination and data sharing. The modern approach to UAP investigation increasingly emphasizes international coordination and data sharing. The phenomena reported in the United States show similarities to encounters documented by other nations, suggesting that UAPs represent a global rather than regional phenomenon. Collaboration with allied nations allows for comparison of investigation methodologies and cross-validation of findings. When similar phenomena are reported independently by multiple countries using different investigation procedures, the consistency of reports strengthens confidence in the reliability of observations. International cooperation also helps address cases that involve objects crossing national boundaries or occurring in international airspace. Such cases require coordination between multiple agencies and nations to develop complete pictures of encounter sequences and characteristics. The sharing of analytical methodologies and technological capabilities helps improve investigation quality worldwide. Nations with advanced sensor systems can assist others in developing their investigation capabilities, while countries with extensive historical databases can provide valuable comparative data for pattern analysis. Looking forward, the evolution of official reporting as we reflect on the significance of the 2023 Consolidated Report. It's important to recognize that this document represents just the beginning of a new era in official UAP reporting. Future reports will likely show continued improvements in data collection, analysis methodologies, and international coordination. The establishment of regular reporting schedules ensures that UAP investigation will receive ongoing attention and resources, rather than sporadic interest. This consistency is crucial for building comprehensive understanding of phenomena that may exhibit long-term patterns not apparent in short-term studies. Technological advancement will continue to improve investigation capabilities. Better sensors, more sophisticated analysis tools, and enhanced data correlation systems will provide investigators with increasingly powerful tools for understanding UAP encounters. The growing acceptance of UAP research as a legitimate scientific endeavor will likely attract more qualified researchers and additional resources to the field. This expansion of expertise and capability promises to accelerate progress in understanding these enduring mysteries. Chapter 5. Verified Testimonies and Congressional Hearings. The halls of democracy meet the unknown as our peaceful journey through the night continues. We now turn to one of the most remarkable developments in the modern UAP era, the testimony of military personnel before the United States Congress. In the hallowed halls where the nation's most important decisions are made, experienced pilots and intelligence officials have shared their encounters with phenomena that challenge our understanding of aerial technology and capabilities. These congressional hearings represent a dramatic departure from decades of official silence and skepticism. For the first time in generations, military personnel are speaking publicly, under oath, about their encounters with unidentified aerial phenomena. Their testimony, delivered with the gravity befitting the legislative chamber, has provided the American public and the world with unprecedented insight into the reality of UAP encounters. The significance of these hearings extends beyond the specific testimony provided. They represent an institutional acknowledgement that UAPs deserve serious attention from the highest levels of government. When Congress dedicates time and resources to examining a phenomenon, it signals that the topic has moved from the margins of official discourse to the center of national security consideration. The July 2023 congressional hearing on a warm summer day in July 2023, the halls of Congress witnessed testimony that would have seemed impossible just a few years earlier. Military personnel, intelligence officials, and other government witnesses appeared before congressional committees to discuss UAP encounters openly and on the record. The hearing, broadcast live and covered extensively by major media outlets, marked a historic moment in the official treatment of aerial anomalies. The atmosphere in the hearing room reflected the gravity of the subject matter. Members of Congress from both political parties demonstrated serious interest in understanding UAP phenomena and their implications for national security. The bipartisan nature of congressional interest underscored that UAPs have transcended political divisions to become a matter of shared concern about aviation safety and national defense. The witnesses who appeared before Congress represented a cross-section of the military and intelligence communities. Their diverse backgrounds and experiences provided multiple perspectives on UAP encounters and their significance. The breadth of testimony helped paint a comprehensive picture of how these phenomena affect various aspects of government operations. The hearing format allowed for detailed questioning and follow-up that revealed aspects of UAP encounters not apparent in written reports. The interactive nature of congressional testimony provided opportunities for clarification and elaboration that enhanced public understanding of the complexity and significance of these phenomena. Ryan Graves, a pilot's perspective among the most compelling witnesses, was Ryan Graves, a former United States Navy pilot with extensive experience in high-performance military aircraft. Graves's testimony provided a first-hand account of UAP encounters from the perspective of someone whose professional life depended on accurate observation and assessment of aerial phenomena. Graves testified under oath that UAP encounters were not rare, isolated incidents, but rather frequent occurrences during military operations. His statement that our skies are full of UAPs provided a striking characterization of the prevalence of these phenomena from the perspective of military aviation. This testimony challenged public perceptions that UAP encounters are unusual or infrequent events. The pilot's testimony emphasized that UAP sightings are neither rare nor isolated, directly contradicting decades of official suggestions that such encounters were uncommon or insignificant. Graves's characterization of UAPs as presenting a significant challenge to national security elevated the discussion from curiosity about unusual sightings to serious consideration of potential threats or capabilities. Graves described how UAP encounters had become routine during certain military operations, suggesting that these phenomena represent a persistent, rather than occasional aspect of military aviation. His testimony indicated that pilots and aircrew had developed informal procedures for dealing with UAP encounters, reflecting the regularity with which such incidents occurred. The pilot's emphasis on the need for systematic reporting without fear of professional retaliation addressed one of the long-standing barriers to comprehensive UAP investigation. Graves testified that both military and civilian pilots should be able to report unusual encounters without concern for career consequences, acknowledging that historical stigma had likely resulted in significant underreporting of incidents. The broader context of military testimony. Graves's testimony was representative of a broader pattern of military personnel coming forward with accounts of UAP encounters. The willingness of trained, experienced military personnel to testify publicly about these phenomena represents a significant shift from the silence that characterized earlier eras. The credibility of military witnesses carries particular weight in UAP discussions. These individuals are trained observers whose professional responsibilities require accurate assessment of aerial phenomena. Their testimony about encounters that defy conventional explanation cannot be easily dismissed as misidentification or misinterpretation. The consistency of accounts from multiple military witnesses across different time periods and geographic locations strengthens the credibility of UAP reports. When independent observers describe similar phenomena, using similar language and emphasizing similar characteristics, the likelihood of coordinated deception or systematic misidentification decreases significantly. The detailed nature of military testimony also provides valuable information for ongoing investigation efforts. Professional pilots can describe flight characteristics, estimate sizes and distances, and assess capabilities with greater accuracy than typical civilian observers. Their accounts provide investigators with more precise data for analysis and comparison. Addressing unverified claims, an important aspect of the congressional hearings, was the careful distinction between verified observations and unverified claims that have circulated in UAP discussions. Pentagon officials and other witnesses took care to clarify that extraordinary claims lacking supporting evidence should not be confused with documented encounters that warrant serious investigation. During the hearings, officials specifically addressed claims about alleged alien remains or recovered extraterrestrial technology, stating clearly that the Pentagon had no evidence supporting such assertions. This careful distinction helped separate documented aerial phenomena from unsupported speculation that has historically complicated UAP discussions. The emphasis on verified information reflects the commitment to evidence-based analysis that characterizes modern UAP investigation. Rather than embracing or dismissing claims based on their sensational nature, investigators focus on what can be documented and verified through multiple sources and analytical methods. This approach helps maintain the credibility of official UAP investigation by avoiding association with unsubstantiated claims that could undermine public confidence in the research process. By clearly distinguishing between verified observations and unverified assertions, officials help ensure that legitimate investigation efforts are not compromised by speculative theories. Bipartisan political support. One of the most remarkable aspects of the congressional hearings was the bipartisan nature of political interest in UAP investigation. Members of Congress from both major political parties demonstrated serious concern about aerial anomalies and their potential implications for national security and aviation safety. This bipartisan support reflects the apolitical nature of UAP encounters themselves. These phenomena affect military operations and aviation safety, regardless of political affiliation or ideology. The shared concern about national security and public safety has created common ground that transcends typical political divisions. The bipartisan approach has also helped ensure continued funding and institutional support for UAP investigation efforts. When both political parties support research programs, those programs are more likely to receive consistent resources and attention, regardless of changes in political control. Republican and Democratic members of Congress have both emphasized the importance of transparency in UAP investigation, while acknowledging legitimate national security concerns that might require classification of certain information. This balanced approach helps maintain public trust while protecting sensitive intelligence sources and methods. The push for transparency, congressional hearings, have consistently emphasized the importance of government transparency regarding UAP encounters and investigations. Lawmakers from both parties have argued that the American public deserves access to information about phenomena that affect national security and aviation safety. The push for transparency reflects recognition that decades of government secrecy surrounding UAPs have contributed to speculation and conspiracy theories that may be more harmful than the facts themselves. By providing accurate, official information about UAP encounters and investigations, the government can counter misinformation while building public trust. However, transparency efforts must balance public access to information with legitimate national security concerns. Some UAP encounters may involve classified military capabilities or intelligence sources that require protection. The challenge is providing meaningful transparency without compromising sensitive operations or capabilities. Congressional oversight helps ensure that classification decisions are justified and that secrecy is not used to avoid accountability or hide embarrassing information. The ongoing relationship between Congress and executive branch agencies provides a mechanism for continued monitoring of UAP investigation efforts. The role of science in congressional testimony, congressional hearings, have consistently emphasized the importance of scientific methodology in UAP investigation. Witnesses and lawmakers alike have stressed that understanding these phenomena requires rigorous application of scientific principles, rather than speculation or assumption. Scientific experts who have testified before Congress have outlined the data collection and analysis procedures needed to advance understanding of UAP encounters. Their testimony has helped establish standards for evidence quality and analytical rigor that guide ongoing investigation efforts. The emphasis on science has also helped distinguish legitimate UAP research from sensational or pseudoscientific approaches that have historically surrounded the topic. By insisting on scientific methodology, Congress has helped establish UAP investigation as a legitimate field of inquiry deserving of serious attention and resources. Scientists testifying before Congress have also outlined the potential benefits of UAP research for advancing human knowledge and capabilities. Even if UAPs prove to have conventional explanations, The process of investigating them may yield insights into atmospheric physics, sensor technology, or other scientific areas. International implications. Congressional testimony has acknowledged that UAP encounters are not limited to United States airspace or military operations. The global nature of these phenomena has implications for international cooperation and information sharing that extend beyond national boundaries. Witnesses have testified about the importance of coordinating UAP investigation efforts with allied nations and international organizations. Sharing data and analytical methodologies can improve understanding of phenomena that may cross national boundaries or affect international aviation operations. The international dimension of UAP encounters also raises questions about whether these phenomena represent foreign technology or capabilities that could affect global security relationships. Congressional testimony has addressed these concerns, while emphasizing that current evidence does not support conclusions about the origin or control of UAP phenomena. International cooperation in UAP research may also contribute to broader scientific collaboration and diplomatic relationships. The shared challenge of understanding aerial anomalies provides opportunities for international partnership that could benefit multiple areas of research and development. The evolution of official attitudes. Congressional hearings have documented the dramatic evolution in official attitudes toward UAP encounters and investigation. Witnesses have described how institutional responses have changed from dismissal and ridicule to serious investigation and analysis. This evolution reflects broader changes in scientific understanding, technological capabilities, and institutional culture that have made serious UAP investigation possible. The combination of better detection equipment, improved analytical methods, and changed organizational attitudes has created an environment where UAP research can proceed effectively. The testimony has also revealed how past approaches to UAP investigation may have discouraged reporting and limited understanding of these phenomena. The recognition of these historical limitations has informed current efforts to create more effective and comprehensive investigation procedures. Looking forward, congressional oversight helps ensure that UAP investigation efforts continue to evolve and improve based on new evidence and analytical capabilities. The ongoing relationship between legislative and executive branches provides accountability and direction for future research efforts. Implications for military personnel. Congressional testimony has had significant implications for military personnel who encounter UAPs during their operations. The official acknowledgement of these phenomena and the encouragement of systematic reporting represent major changes in military culture and procedures. The testimony has helped remove the stigma that historically discouraged military personnel from reporting unusual encounters. Witnesses have emphasized that accurate reporting of all aerial phenomena is essential for aviation safety and operational effectiveness, regardless of whether those phenomena can be immediately explained. The development of formal reporting procedures and investigation protocols provides military personnel with clear channels for documenting UAP encounters. These systems help ensure that valuable information reaches investigators, while protecting the careers and reputations of those who report unusual observations. Training and education programs are being developed to help military personnel recognize and document UAP encounters effectively. These programs emphasize the importance of accurate observation and reporting, while providing guidance on distinguishing between known and unknown phenomena. The future of congressional oversight. As we conclude our examination of congressional testimony regarding UAPs, it's important to recognize that these hearings represent the beginning, rather than the end of legislative oversight in this area. Future hearings will likely provide updates on investigation progress and address new developments in UAP research. The establishment of regular congressional oversight helps ensure continued attention and resources for UAP investigation efforts. This ongoing relationship between legislative and executive branches provides accountability and direction that may be crucial for long-term progress in understanding these phenomena. Future hearings may also address specific aspects of UAP investigation in greater detail, such as international cooperation, technological development, or scientific methodology. The flexibility of congressional oversight allows for focused examination of particular issues as they arise. The evolution of congressional interest in UAPs reflects broader changes in how institutions approach unexplained phenomena. The willingness to acknowledge uncertainty while pursuing systematic investigation represents a mature approach to scientific inquiry that may serve as a model for addressing other challenging questions. Chapter 6. Scientific analysis of the phenomenon. The laboratory meets the unexplained in the quiet hours of our continuing journey. We now turn to perhaps the most significant development in modern UAP research: the formal entry of mainstream science into the investigation of aerial anomalies. As you rest peacefully, scientists around the world are applying the rigorous methodologies of their disciplines to phenomena that have puzzled humanity for decades. The transformation of UAP research from speculation to systematic scientific inquiry represents a fundamental shift in how we approach the unknown. No longer relegated to the margins of legitimate research, the study of unidentified aerial phenomena now engages some of the world's most respected scientific institutions and researchers. This evolution from curiosity to rigorous investigation marks a new chapter in our understanding of these enduring mysteries. The scientific approach to UAP research brings powerful tools and methodologies that were unavailable to earlier investigators. Advanced sensors, sophisticated analytical techniques, and computational capabilities that can process vast amounts of data provide modern researchers with unprecedented abilities to examine and understand aerial anomalies. Perhaps most importantly, the scientific approach brings a culture of skeptical inquiry that demands evidence, encourages peer review, and accepts uncertainty when data is insufficient for definitive conclusions. This intellectual rigor helps ensure that UAP research progresses based on evidence rather than assumption or speculation. NASA historic engagement. The National Aeronautics and Space Administration's formal engagement with UAP research represents one of the most significant developments in the scientific approach to these phenomena. NASA entry into UAP research brings not only the agency's scientific expertise, but also its institutional credibility and commitment to transparent, evidence-based investigation. In September 2023, NASA released a comprehensive study that acknowledged the current limitations in UAP research while outlining pathways for future scientific progress. The study, conducted by an independent panel of experts from various scientific disciplines, represented the first formal scientific assessment of UAP phenomena by a major government science agency in decades. The NASA study's acknowledgement that few high-quality records exist for UAP encounters reflects the scientific standard for evidence quality. Rather than accepting anecdotal accounts or low-resolution imagery, scientists require data that meets rigorous standards for accuracy, reliability, and verifiability. This high standard ensures that scientific conclusions rest on solid foundations. The study's frank admission that current data is insufficient to draw firm conclusions about UAP nature demonstrates the scientific commitment to intellectual honesty. Rather than forcing premature conclusions based on inadequate evidence, scientists acknowledge uncertainty while working to improve data quality and analytical capabilities. The challenge of scientific standards applying scientific methodology to UAP research presents unique challenges that distinguish this field from more conventional areas of scientific inquiry. Unlike laboratory experiments that can be controlled and repeated, UAP encounters occur spontaneously under uncontrolled conditions, making systematic study difficult. The ephemeral nature of most UAP encounters creates additional challenges for scientific investigation. Many sightings last only seconds or minutes, providing limited time for detailed observation or measurement. The unpredictable timing and location of encounters make it difficult to deploy specialized equipment or arrange for multiple observers. The variety of conditions under which UAP encounters occur also complicates scientific analysis. Different atmospheric conditions, lighting situations, and observational platforms can significantly affect the appearance and characteristics of aerial phenomena. Understanding these variables is crucial for accurate interpretation of observational data. Despite these challenges, scientists are developing methodologies specifically designed for UAP research. These approaches emphasize the importance of multiple independent observations, the use of calibrated instruments, and the careful documentation of environmental conditions that might affect observations. Data quality and collection standards. Modern scientific UAP research places primary emphasis on data quality and collection standards that ensure observations can be analyzed reliably. Scientists have established criteria for evaluating the credibility and utility of UAP reports based on factors such as observer qualifications, instrumentation used, and environmental conditions. High-quality UAP data typically involves multiple independent observers using calibrated instruments under documented conditions. The most valuable cases combine visual observations with radar tracking, photographic or video documentation, and detailed records of atmospheric and environmental factors that might influence observations. Scientists have also developed protocols for collecting new UAP data that meet scientific standards. These protocols emphasize the importance of immediate documentation, the use of multiple sensors when possible, and the preservation of all relevant information for subsequent analysis. The establishment of standardized data collection procedures helps ensure that future UAP encounters can contribute meaningfully to scientific understanding. By collecting data systematically and consistently, researchers can build databases that support statistical analysis and pattern recognition, removing bias and encouraging reporting. One of the most important aspects of the scientific approach to UAP research is the commitment to removing bias and encouraging honest reporting of unusual observations. Scientists recognize that preconceived notions about what UAPs might represent can influence both the collection and analysis of data. The historical stigma surrounding UAP reports has likely resulted in significant underreporting of encounters, particularly among professional pilots and military personnel, whose careers might be affected by associations with unexplained phenomena. Removing this stigma is essential for building comprehensive databases of UAP encounters. NASA Administrator Nicola Fox's characterization of UAPs as one of the greatest mysteries of the planet reflects the scientific appreciation for genuine puzzles that challenge current understanding. This respectful approach to unexplained phenomena encourages observers to report encounters without fear of ridicule or professional consequences. The scientific emphasis on data quality over sensational interpretations helps distinguish legitimate research from speculation and conspiracy theories. By focusing on what can be measured and verified, scientists maintain credibility while advancing understanding of these phenomena. International cooperation and data sharing. Scientific UAP research increasingly emphasizes international cooperation and data sharing among researchers worldwide. The global nature of UAP encounters makes international collaboration essential for understanding whether these phenomena exhibit consistent characteristics across different geographic regions and observational contexts. International pilot reporting initiatives have been established to collect UAP encounter data from commercial and military aviation operations worldwide. These programs provide standardized reporting procedures and protection for pilots who document unusual aerial phenomena during flight operations. The sharing of analytical methodologies and technological capabilities helps improve investigation quality across the international research community. Countries with advanced sensor systems can assist others in developing their investigation capabilities, while nations with extensive historical databases can provide valuable comparative data. International scientific collaboration also helps address cases that involve objects crossing national boundaries or occurring over international airspace. Such cases require coordination between multiple agencies and research institutions to develop complete pictures of encounter sequences and characteristics. Advanced sensor systems and detection networks. Modern scientific UAP research benefits from sensor systems and detection capabilities that far exceed what was available to earlier investigators. Advanced radar networks, space-based observation platforms, and sophisticated atmospheric monitoring systems provide unprecedented capabilities for detecting and tracking aerial anomalies. The James Webb Space Telescope and other advanced astronomical instruments, while primarily designed for space science, possess capabilities that could contribute to UAP research. These systems can detect and track objects at various distances and under different conditions, potentially providing valuable data about aerial phenomena. Ground-based sensor networks designed specifically for UAP detection are being proposed and developed by various research groups. These systems would provide continuous monitoring of selected airspace using multiple sensor types, creating comprehensive records of all aerial activity in monitored regions. The integration of multiple sensor systems promises to overcome many of the limitations that have historically complicated UAP research. When visual observations are combined with radar tracking, thermal imaging, and other detection methods, investigators can build more complete pictures of encounter characteristics and behavior. The role of artificial intelligence in scientific analysis. Artificial intelligence and machine learning technologies are playing increasingly important roles in scientific UAP research. These tools can process vast amounts of sensor data, identify patterns that might not be apparent to human analysts, and flag potential UAP encounters for detailed investigation. Pattern recognition algorithms can analyze video footage from multiple sources to identify objects exhibiting unusual flight characteristics. These systems can process hours of surveillance footage in minutes, identifying sequences that warrant further investigation by human experts. Machine learning systems can correlate UAP reports with various environmental factors, potentially identifying conditions that are associated with increased encounter rates. Such correlations might provide insights into the nature of UAP phenomena or help predict when encounters are most likely to occur. Natural language processing technologies can analyze large databases of UAP reports to identify common characteristics and patterns in encounter descriptions. These tools can process thousands of reports to identify recurring themes that might provide clues about the nature of these phenomena. Academic research and peer review. The growing acceptance of UAP research within the academic community represents a crucial development for the scientific study of these phenomena. Universities and research institutions that once avoided the topic are now supporting systematic research programs and publishing peer-reviewed studies on various aspects of UAP encounters. Academic research brings several advantages to UAP studies: access to sophisticated analytical equipment, collaboration with experts from multiple disciplines, and subjection to peer review processes that help ensure research quality and credibility. The involvement of academic institutions helps legitimize UAP research as a serious scientific endeavor. Peer review processes, fundamental to scientific research, are gradually being applied to UAP studies. Research papers on UAP-related topics are beginning to appear in mainstream scientific journals, where they undergo the same scrutiny as any other scientific work. This development represents a crucial step toward establishing UAP research as a legitimate scientific discipline. The interdisciplinary nature of UAP research requires collaboration among experts from various fields: physics, atmospheric science, psychology, engineering, and others. Academic institutions are well positioned to facilitate such collaboration and provide the diverse expertise needed for comprehensive UAP investigation. Theoretical frameworks and scientific hypotheses. Scientific UAP research requires the development of testable hypotheses and theoretical frameworks that can guide investigation and analysis. Scientists are proposing various theories to explain UAP encounters, ranging from conventional explanations involving atmospheric phenomena to more exotic possibilities that might require revisions to current scientific understanding. Atmospheric physics provides several potential explanations for some UAP encounters. Ball lightning, plasma phenomena, and unusual atmospheric refractions can create visual effects that might appear anomalous to unfamiliar observers. Scientists are working to better understand these natural phenomena and their potential role in UAP reports. Meteorological conditions can also create unusual aerial effects that might be misinterpreted as artificial objects. Temperature inversions, unusual cloud formations, and atmospheric optical effects can create compelling visual displays that challenge conventional understanding when observed under specific conditions. The possibility of advanced but conventional technology also receives serious scientific consideration. Experimental aircraft, advanced drone systems, or foreign military technology might account for some UAP encounters that appear to involve artificial objects with unusual capabilities. More exotic theoretical frameworks involve possibilities that would challenge current scientific understanding. These might include propulsion technologies based on principles not yet understood by mainstream science, or phenomena related to theoretical physics concepts, such as exotic matter or space-time manipulation. The importance of null results scientific methodology recognizes that null results findings that show no evidence for a particular hypothesis are as valuable as positive results for advancing understanding. In UAP research, investigations that demonstrate conventional explanations for reported encounters are as scientifically important as those that identify genuinely anomalous phenomena. The systematic identification of conventional explanations helps refine understanding of what constitutes genuine anomalies worthy of further investigation. By eliminating cases with mundane explanations, researchers can focus limited resources on encounters that might provide insights into genuinely unknown phenomena. Null results also help calibrate investigation methodologies and identify potential sources of error or bias in analytical procedures. When investigations consistently identify conventional explanations for reported anomalies, this provides confidence in the thoroughness and accuracy of investigation procedures. The willingness to accept null results demonstrates the scientific commitment to following evidence rather than pursuing predetermined conclusions. This intellectual honesty is essential for maintaining the credibility of UAP research within the broader scientific community. Technological innovation in UAP research. The scientific approach to UAP research is driving technological innovation in sensor systems, data analysis methods, and investigation procedures. The unique challenges of studying ephemeral, unpredictable phenomena are spurring development of new detection and analysis capabilities. Advanced imaging systems specifically designed for UAP detection are being developed by various research groups. These systems combine multiple sensor types with sophisticated image processing capabilities to provide comprehensive documentation of aerial phenomena under various conditions. Data fusion technologies that can combine information from multiple sensors and sources are providing investigators with more complete pictures of UAP encounters. These systems can correlate visual observations with radar tracks, thermal signatures, and other sensor data to build comprehensive encounter profiles. Communication networks that can rapidly alert multiple observation stations to potential UAP encounters are being developed to enable coordinated observation efforts. These systems could allow researchers to deploy multiple sensors and observers when encounters are detected in real time. The psychology of scientific observation. Scientific UAP research must account for the psychological factors that can influence human observation and interpretation of unusual phenomena. Even trained, reliable observers can be affected by various cognitive biases and perceptual limitations that must be considered in evaluating testimony and reports. Research in cognitive psychology has revealed how expectation, stress, and environmental factors can influence what people observe and remember. Understanding these factors is crucial for accurately interpreting witness accounts and distinguishing between actual phenomena and perceptual artifacts. The development of structured observation and reporting protocols helps minimize the impact of psychological factors on data collection. These protocols guide observers through systematic documentation procedures designed to capture accurate information while avoiding leading questions or suggestive procedures. Training programs for observers help them recognize and account for potential perceptual limitations and biases. Such training can improve the accuracy and reliability of observational data, while helping observers distinguish between different types of aerial phenomena. Ethical considerations in UAP research. Scientific UAP research raises several ethical considerations related to witness protection, data privacy, and responsible communication of findings. Researchers must balance the scientific value of investigations with respect for the privacy and welfare of individuals who report encounters. Witness protection protocols ensure that individuals who report UAP encounters are not subjected to harassment, ridicule, or professional consequences as a result of their cooperation with scientific investigations. These protections are essential for maintaining voluntary participation in research efforts. Data privacy considerations require careful handling of information that might identify specific individuals, locations, or operational details related to UAP encounters. Researchers must balance transparency with legitimate privacy and security concerns. Responsible communication of research findings requires careful presentation of results that accurately reflects the state of evidence without encouraging speculation or misinterpretation. Scientists must communicate uncertainty honestly, while avoiding either dismissive or sensational characterizations of their findings. The role of citizen science initiatives are playing increasingly important roles in UAP research by engaging amateur observers in systematic data collection efforts. These programs provide training and standardized procedures that help amateur astronomers, aviation enthusiasts, and other interested individuals contribute valuable observations to research databases. Mobile applications and online reporting platforms make it easier for citizen scientists to document and report potential UAP encounters using standardized formats and procedures. These tools help ensure that citizen observations meet quality standards for scientific analysis. Citizen science networks can provide geographic coverage that would be impossible for professional research programs alone. The large number of potential observers involved in citizen science efforts increases the likelihood of documenting rare or unusual phenomena. Quality control procedures help ensure that citizen science contributions meet standards for scientific analysis. These procedures typically involve verification processes and expert review of submitted observations before they are incorporated into research databases. Educational outreach and public understanding. Scientific UAP research includes important educational components designed to improve public understanding of these phenomena and the scientific methods used to study them. Educational programs help distinguish scientific approaches from speculation and conspiracy theories that have historically surrounded UAP topics. Public education about UAP research helps remove stigma that might discourage reporting of encounters, while providing realistic expectations about the pace and nature of scientific progress. Educational efforts emphasize the importance of evidence-based conclusions and systematic investigation. Science education programs use UAP research as examples of how scientific methodology can be applied to challenging and unconventional problems. These programs demonstrate how scientists approach unknown phenomena systematically and objectively. Media engagement by scientific researchers helps ensure accurate public communication about UAP research findings and methodologies. Scientists work with journalists and media outlets to provide accurate information that avoids both dismissive and sensational characterizations. Future directions in scientific UAP research. As we approach the conclusion of our scientific exploration, it's important to consider the future directions that UAP research might take as it becomes more established within the scientific community. Several promising developments are likely to advance our understanding significantly in the coming years. Improved sensor technologies will provide researchers with better capabilities for detecting and documenting aerial phenomena. Next-generation radar systems, advanced optical sensors, and space-based observation platforms will offer unprecedented abilities to track and characterize unusual aerial objects. Artificial intelligence and machine learning technologies will continue to improve, providing researchers with more powerful tools for analyzing large datasets and identifying patterns that might not be apparent to human analysts. These technologies may prove crucial for processing the vast amounts of data that comprehensive UAP monitoring would generate. International cooperation in UAP research is likely to expand as more countries and institutions recognize the scientific value of systematic investigation. Coordinated global monitoring efforts could provide comprehensive coverage and enable detection of phenomena that might be missed by regional programs. The establishment of dedicated research institutions focused specifically on UAP studies could accelerate progress by providing stable funding, specialized equipment, and concentrated expertise. Such institutions could serve as focal points for international collaboration and scientific advancement. The integration of multiple disciplines, future scientific UAP research, will likely require even greater integration of multiple scientific disciplines to address the complex challenges these phenomena present. Atmospheric physicists, aerospace engineers, cognitive psychologists, and experts from other fields will need to work together to develop comprehensive understanding. The interdisciplinary nature of UAP research creates opportunities for scientific advancement in multiple areas. Even if UAPs ultimately prove to have conventional explanations, the process of investigating them is likely to yield insights into atmospheric physics, sensor technology, human perception, and other scientific domains. Cross-disciplinary collaboration also helps ensure that research approaches are comprehensive and balanced. Different disciplines bring different perspectives and methodologies that can complement each other and provide more complete understanding of complex phenomena. The establishment of formal interdisciplinary research programs could help coordinate efforts across different scientific communities and ensure that UAP research benefits from the full range of relevant expertise. The promise of scientific understanding as we conclude our exploration of the scientific approach to UAP research. It's worth reflecting on the promise that systematic, evidence-based investigation holds for eventually understanding these phenomena. While many questions remain unanswered, the application of rigorous scientific methodology provides the best hope for eventual resolution of these enduring mysteries. The transformation of UAP research from speculation to science represents a fundamental shift in how we approach the unknown. By applying the same methodologies that have advanced human understanding in countless other areas, scientists are bringing powerful tools to bear on phenomena that have puzzled humanity for decades. Whether UAPs ultimately prove to represent advanced technology, natural phenomena we don't yet understand, or something else entirely, the scientific approach ensures that our conclusions will be based on evidence rather than assumption. This commitment to empirical investigation, regardless of where it leads, represents science at its best. The patience required for systematic scientific investigation may frustrate those seeking immediate answers, but this methodical approach provides the best foundation for reliable, lasting understanding. Science advances through careful accumulation of evidence and gradual refinement of theories, not through dramatic breakthroughs or spectacular revelations. A new chapter in human understanding as you prepare for deeper rest. Consider the remarkable journey we've taken through the modern landscape of UAP research. From the comprehensive government reports documenting hundreds of encounters to the sworn testimony of military personnel before Congress, from NASA scientific panels to international cooperation efforts, we've witnessed an unprecedented transformation in how institutions approach these enduring mysteries. The shift from ridicule to serious scientific inquiry represents more than just changing attitudes toward a single phenomenon. It reflects humanity's growing sophistication in applying scientific methodology to challenging questions and our willingness to acknowledge the limits of current knowledge while working systematically to expand understanding. The scientists working quietly in laboratories and observatories around the world, the military personnel documenting encounters with professional precision, the government officials providing transparent reporting, and the citizen scientists contributing observations all participate in humanity's eternal quest to understand the unknown. Tomorrow, in our final segment, we will explore the broader implications of UAP research for science, technology, and human understanding. We'll examine the potential impact of these investigations on our view of technology, physics, and our place in the universe. We'll consider how the methodical pursuit of understanding serves as a model for approaching other challenging questions about our world and beyond. For now, rest peacefully, knowing that the careful work of investigation continues. In observatories and laboratories, in government offices and academic institutions, dedicated researchers apply the tools of science to phenomena that have captured human imagination for generations. Their patient, methodical work brings us closer to understanding, one observation, one analysis, one carefully documented case at a time. The night sky above us holds the same mysteries that have puzzled humanity throughout history, but our ability to investigate and understand those mysteries grows ever stronger. In this continuing quest for knowledge, we see humanity at its most noble, curious, persistent, and committed to understanding truth through evidence and reason rather than speculation and assumption. Sweet dreams, filled with wonder at the vast universe around us, and appreciation for those who dedicate their lives to expanding the boundaries of human knowledge. The journey toward understanding continues, carrying us ever closer to resolving some of the most intriguing mysteries of our time. Part 3. Implications and Future National Security, Policy and the Path Forward. Duration, approximately 90 minutes. Transition. From evidence to implications, welcome to the final chapter of our peaceful journey through the world of unidentified aerial phenomena. As the night deepens around us and you settle into these closing hours of exploration, we turn our attention from what we have observed to what these observations might mean for our security, our policies, and our future as a civilization seeking to understand the unknown. Throughout our journey together, we have traveled from the historical foundations of UAP investigation through the modern renaissance of scientific inquiry. We have examined official reports, heard sworn testimony from military personnel, and explored how the scientific community approaches these enduring mysteries. Now, as we prepare to conclude our exploration, we must consider the broader implications of what we have learned. The phenomena we have discussed do not exist in isolation. They intersect with questions of national security, influence government policy, and shape public understanding of science and technology. The way we respond to UAPs reflects not only our investigative capabilities, but also our values, our priorities, and our approach to the unknown. As you rest comfortably in these final hours of our documentary, let your mind wander through the complex web of implications that surround UAP research. Consider how the careful documentation of unexplained phenomena connects to the broader challenges of maintaining security, developing policy, and advancing human knowledge in an uncertain world. Chapter 7. National Security Implications and Public Policy. The security dimension of the unknown. In the quiet hours when most of the world sleeps, intelligence analysts and security professionals continue their vigilant watch over the safety of nations and their citizens. Among the many challenges they face, few are as complex and multifaceted as the implications of unidentified aerial phenomena for national security and public safety. The modern approach to UAP investigation recognizes that these phenomena, whatever their ultimate origin, intersect with fundamental questions of national defense, aviation safety, and homeland security. The presence of unidentified objects in controlled airspace raises immediate questions about the effectiveness of detection systems, the adequacy of response procedures, and the potential for threats to both military and civilian operations. Unlike the dismissive attitudes that characterized earlier eras, contemporary security professionals understand that UAPs represent legitimate concerns that require systematic analysis and appropriate response. The transformation from ridicule to serious attention reflects recognition that unexplained phenomena in sensitive airspace cannot be ignored, regardless of what they might ultimately prove to represent. The security implications of UAPs extend beyond simple curiosity about unusual sightings. These phenomena affect operational planning, resource allocation, and strategic thinking about both current and future threats. The systematic documentation and analysis of UAP encounters contributes to broader understanding of airspace security and technological capabilities. Intelligence assessment and foreign technology concerns intelligence experts approach UAP phenomena with particular attention to the possibility that some encounters might involve advanced foreign technology or capabilities. This concern drives much of the official interest in systematic UAP investigation and analysis, as understanding the source and capabilities of unidentified aerial objects could have significant implications for national security planning. The possibility that UAPs might represent foreign surveillance platforms, experimental aircraft, or advanced military capabilities requires careful analysis and appropriate response. Intelligence agencies must evaluate whether reported flight characteristics are consistent with known foreign technological capabilities, or whether they might indicate breakthrough developments that could affect strategic balance. The rapid advancement of drone technology and autonomous systems has created new categories of potential aerial threats that require updated detection and response capabilities. Modern UAP investigation must account for the possibility that some encounters involve advanced unmanned systems operating with capabilities that exceed those of conventional aircraft. However, intelligence assessment also recognizes that not all UAP encounters necessarily involve foreign technology. Natural phenomena, equipment malfunctions, and perceptual factors can create apparent anomalies that require investigation but do not represent actual security threats. The challenge is distinguishing between genuine threats and false alarms while maintaining appropriate vigilance. The international dimension of UAP encounters adds complexity to intelligence assessment. When similar phenomena are reported by multiple nations using independent detection systems, this suggests either coordinated foreign operations or phenomena that transcend national boundaries and conventional technological explanations. Aviation safety and operational security. Aviation safety represents one of the most immediate and practical concerns related to UAP encounters. When unidentified objects appear in controlled airspace, they create potential collision hazards for both military and civilian aircraft. Understanding and responding to these encounters is essential for maintaining the safety of flight operations. The Federal Aviation Administration and international aviation authorities must consider how UAP encounters affect flight safety protocols and air traffic management procedures. When pilots report unusual objects or phenomena, air traffic controllers must make rapid decisions about flight path modifications, airport operations, and coordination with military authorities. Military aviation faces additional challenges related to operational security and mission effectiveness. UAP encounters during military operations could potentially compromise missions, reveal operational capabilities, or create vulnerabilities that adversaries might exploit. Understanding these risks is essential for maintaining military effectiveness and security. The development of standardized procedures for responding to UAP encounters helps ensure consistent and appropriate responses that prioritize safety while maintaining operational effectiveness. These procedures must balance the need for immediate safety measures with longer-term investigative requirements. Training programs for pilots, air traffic controllers, and military personnel help ensure that UAP encounters are handled appropriately and documented systematically. Such training emphasizes safety procedures, while providing guidance on reporting requirements and coordination with investigation authorities. The 2021 ODNI Assessment and Security Framework, the 2021 Office of the Director of National Intelligence Preliminary Assessment on UAPs, established a framework for understanding the security implications of these phenomena that continues to guide policy and operational responses. The assessment's conclusion that UAPs pose a flight safety problem and could present a national security challenge provides official recognition of the legitimate security concerns these phenomena represent. The ODNI assessment identified several specific areas of security concern related to UAP encounters. Flight safety issues arise when unidentified objects appear in the same airspace as military or civilian aircraft, creating potential collision hazards and operational complications. These immediate safety concerns require prompt response and systematic tracking. The potential for national security challenges emerges if UAPs represent foreign technology or capabilities that could be used for surveillance, reconnaissance, or other hostile purposes. The assessment noted that the characteristics reported in some UAP encounters, if accurate, would represent significant technological advances that could affect strategic calculations. The assessment also recognized that UAPs might not represent advanced technology at all, but could instead reflect natural phenomena, sensor malfunctions, or other conventional explanations. The security framework must account for this uncertainty while maintaining appropriate vigilance and response capabilities. The ODNI framework emphasizes the importance of collecting additional data and improving analytical capabilities to better understand UAP encounters and their implications. This data-driven approach helps ensure that security responses are proportionate to actual risks, rather than speculation or assumption. Legislative response and policy development. The legislative branch of government has responded to UAP security concerns through a series of policy initiatives designed to improve investigation capabilities, enhance reporting procedures, and ensure appropriate oversight of government response efforts. Since 2019, every National Defense Authorization Act has included provisions related to UAP investigation and reporting. The inclusion of UAP provisions in defense authorization legislation reflects congressional recognition that these phenomena represent legitimate security concerns deserving of systematic attention and adequate resources. The bipartisan nature of this legislative interest demonstrates that UAP security implications transcend political divisions. The NDA 2022 legislation established the All-Domain Anomaly Resolution Office (ARO) as the central government entity responsible for coordinating UAP investigation and analysis across all military services and intelligence agencies. This centralization helps ensure consistent approaches and information sharing among different government organizations. The NDA 2023 further strengthened UAP investigation capabilities by establishing secure reporting channels that protect personnel who report encounters from retaliation or career consequences. These protections address historical barriers that may have discouraged reporting and limited the comprehensiveness of UAP databases. Subsequent legislation has continued to refine and expand UAP investigation authorities while maintaining appropriate oversight and accountability. Congressional committees regularly receive briefings on UAP investigation progress and findings, ensuring that legislative branch maintains awareness of developments in this area. The legislative approach balances the need for transparency and public accountability with legitimate national security concerns that may require classification of certain information. This balance helps maintain public trust while protecting sensitive sources and methods. International cooperation and diplomatic implications. UAP encounters often occur in international airspace or involve objects that cross national boundaries, creating requirements for international cooperation and coordination. The global nature of these phenomena necessitates diplomatic engagement and information sharing among allied nations. NATO and other international security organizations have begun developing frameworks for sharing UAP-related information among member nations. These arrangements help ensure that encounters affecting multiple countries are analyzed comprehensively, and that responses are coordinated appropriately. The diplomatic implications of UAP encounters include questions about sovereignty, territorial airspace, and international aviation agreements. When unidentified objects appear to violate national airspace, governments must determine appropriate responses while considering diplomatic relationships and international law. Information sharing agreements allow countries with advanced detection capabilities to assist allies in analyzing UAP encounters that occur in their territories. Such cooperation enhances overall understanding while strengthening international security relationships. The possibility that UAPs might represent technology from foreign adversaries adds complexity to international diplomatic relationships. Countries must balance the need to protect sensitive information about their detection capabilities with the benefits of cooperation in understanding potentially threatening phenomena. International scientific cooperation in UAP research complements diplomatic and security cooperation by providing neutral frameworks for information sharing and analysis. Scientific collaboration can continue even when political relationships are strained, providing valuable channels for communication and understanding. Homeland security and critical infrastructure protection. UAP encounters near critical infrastructure facilities raise specific security concerns related to homeland security and the protection of essential services. When unidentified objects are observed near power plants, military installations, or other sensitive facilities, security personnel must assess potential threats and implement appropriate protective measures. The Department of Homeland Security includes UAP considerations in its threat assessment and response planning processes. This integration ensures that unusual aerial phenomena are considered alongside other potential threats to homeland security and public safety. Critical infrastructure operators have developed procedures for reporting and responding to UAP encounters that might affect their facilities or operations. These procedures help ensure consistent responses while providing valuable information for ongoing threat assessment efforts. The potential for UAPs to interfere with critical infrastructure operations, whether intentionally or inadvertently, requires ongoing monitoring and analysis. Understanding how these phenomena might affect essential services helps inform protective measures and contingency planning. Cybersecurity considerations also arise when UAP encounters involve apparent interference with electronic systems or communication networks. Security professionals must determine whether such effects represent actual technological capabilities or coincidental equipment malfunctions. The coordination between federal agencies, state and local authorities, and private sector infrastructure operators helps ensure comprehensive awareness and response to UAP encounters that might affect homeland security. Economic and technological implications. The systematic investigation of UAPs has economic implications related to defense spending, research and development priorities, and technological advancement. Government investment in UAP investigation capabilities contributes to broader advances in sensor technology, data analysis, and aerospace engineering. Defense contractors and technology companies involved in UAP investigation programs benefit from the development of advanced detection and analysis systems. These technological advances often have applications beyond UAP research, contributing to broader technological progress and economic development. The commercial aviation industry must consider UAP implications for flight safety procedures, pilot training, and air traffic management systems. These considerations affect operational costs and safety investments, while contributing to overall aviation industry development. Research and development investments motivated by UAP investigation often yield benefits for broader scientific and technological advancement. Improved sensor systems, enhanced data analysis capabilities, and better understanding of atmospheric phenomena benefit multiple fields beyond UAP research. The potential discovery of advanced technological principles through UAP investigation could have transformative economic implications, though such possibilities remain speculative based on current evidence. The systematic investigation process itself contributes to technological advancement regardless of UAP origins. International competition in UAP investigation capabilities mirrors broader technology competition among nations. Countries invest in advanced detection and analysis systems, partly to ensure they are not disadvantaged in understanding potential foreign technological capabilities. Public safety and emergency response, local and state emergency response agencies must consider how UAP encounters might affect public safety and emergency operations. Training and coordination procedures help ensure that first responders can handle UAP-related incidents appropriately while maintaining public safety. Communication strategies for UAP incidents must balance the need for public information with the importance of preventing panic or misunderstanding. Emergency management agencies work with federal authorities to develop appropriate public communication procedures for various types of UAP encounters. Medical and psychological support services may be required for individuals who experience traumatic or confusing UAP encounters. Emergency response systems must be prepared to provide appropriate care while supporting ongoing investigation efforts. The coordination between federal investigation authorities and local emergency response agencies ensures that UAP incidents receive appropriate immediate response while supporting longer-term investigation and analysis requirements. Public education about UAPs and appropriate reporting procedures helps ensure that citizens can contribute to investigation efforts while understanding the scientific and security context of these phenomena. Community preparedness planning increasingly includes consideration of how unusual or unexplained events, including UAP encounters, might affect local emergency response capabilities and public safety operations. Privacy and civil liberties considerations, UAP investigation programs must balance security and scientific requirements with constitutional protections for privacy and civil liberties. The collection and analysis of UAP-related data must comply with legal frameworks protecting individual rights and freedoms. Surveillance systems designed to detect UAPs may also collect information about civilian activities and movements. Privacy protection procedures ensure that such information is handled appropriately and that civilian privacy rights are respected while maintaining investigation capabilities. The protection of witness identities and personal information requires careful procedures that balance the value of testimony with individual privacy rights. Witnesses must be assured that their cooperation with investigation efforts will not result in unwanted publicity or harassment. Congressional oversight of UAP investigation programs includes attention to civil liberties and privacy protections. Regular review helps ensure that investigation authorities are exercised appropriately and that constitutional rights are protected. Legal frameworks governing UAP investigation must address questions about search and seizure, surveillance authorities, and information sharing, while maintaining appropriate protections for individual rights and freedoms. The development of automated detection systems raises questions about the scope of surveillance and the protection of privacy in public spaces. These systems must be designed and operated in ways that respect civil liberties, while providing necessary security capabilities. Social and cultural impact. The official recognition and investigation of UAPs has significant social and cultural implications that extend beyond immediate security and policy concerns. Public attitudes towards science, technology, and government transparency are influenced by how institutions handle unexplained phenomena. Educational implications arise as UAP research demonstrates the application of scientific methodology to challenging and unconventional problems. Science education programs increasingly use UAP investigation as examples of systematic inquiry and evidence-based analysis. Media coverage of UAP investigations affects public understanding and expectations about both the phenomena and the investigation process. Responsible journalism helps ensure accurate public information while avoiding sensationalism that might undermine scientific credibility. Religious and philosophical perspectives on UAPs contribute to broader cultural discussions about humanity's place in the universe and the possibility of non-human intelligence. These discussions reflect deep human questions about existence, purpose, and cosmic significance. The democratization of information about UAPs through official disclosure and scientific investigation helps counter conspiracy theories and misinformation that have historically surrounded these phenomena. Transparent, evidence-based approaches support informed public discourse. Cultural representations of UAPs in entertainment, literature, and art both reflect and influence public attitudes toward these phenomena. The evolution from science fiction fantasy to scientific investigation marks a significant cultural shift in how society approaches the unknown. Future policy challenges. Looking ahead, policymakers face several emerging challenges related to UAP investigation and response. Technological advancement will continue to create new detection capabilities, while also generating new types of aerial phenomena that might be misidentified as anomalous. International cooperation frameworks will require ongoing development as more countries establish UAP investigation programs and sharing arrangements. Diplomatic protocols for handling UAP incidents involving multiple nations will need refinement and expansion. Legal and regulatory frameworks may require updating as UAP investigation reveals new information about airspace security, aviation safety, and potential technological capabilities. Current laws and regulations may prove inadequate for addressing novel situations that arise from ongoing investigation efforts. Resource allocation decisions will become increasingly important as UAP investigation programs expand and require sustained funding. Policymakers must balance UAP investigation requirements with other national security and scientific research priorities. Public communication strategies will require ongoing refinement as investigation efforts reveal new information and public understanding evolves. Maintaining appropriate transparency while protecting sensitive information will remain a challenging balance. The integration of UAP considerations into broader policy areas, from aviation regulation to international security cooperation, will require coordination among multiple government agencies and policy communities. This integration must occur without disrupting other important policy objectives. Chapter 8. Conclusions and looking ahead, the current state of understanding as we enter the final phase of our contemplative journey through the world of unidentified aerial phenomena. It is time to reflect on what we have learned and what questions remain. After decades of investigation, thousands of reported encounters, and unprecedented levels of official transparency, we find ourselves in a unique position to assess our current understanding of these enduring mysteries. The evidence we have examined throughout our journey tells a consistent story. UAPs exist as observed phenomena that affect military operations, civilian aviation, and public consciousness. The documentation is extensive, the witnesses are credible, and the investigations are systematic. What we observe is real, even when we cannot yet explain what we are observing. Yet our understanding remains incomplete. Despite the best efforts of investigators using the most advanced analytical tools available, many UAP encounters continue to resist conventional explanation. This persistent mystery reflects not the failure of investigation, but rather the complexity of the phenomena and the limitations of current knowledge and technology. The transformation we have witnessed from dismissal to serious investigation represents a fundamental shift in how institutions approach unexplained phenomena. This evolution demonstrates humanity's growing sophistication in applying scientific methodology to challenging questions while acknowledging the boundaries of current understanding. What official investigations have revealed? The comprehensive examination of official investigations, from Project Blue Book through modern RO reports, reveals consistent patterns that help us understand both the phenomena and our response to them. Project Blue Book's analysis of over 12,000 cases in the mid-20th century concluded that while most reports had conventional explanations, a significant percentage remained unexplained even after thorough investigation. This pattern has continued into the modern era. The 2023 Consolidated Report, examining 757 recent cases, found conventional explanations for nearly 300 incidents, while acknowledging that hundreds of others require further investigation. The consistency of this pattern across different time periods, investigation methodologies, and technological capabilities suggests that UAPs represent genuine puzzles rather than systematic misidentification or institutional incompetence. Importantly, both historical and contemporary investigations have reached similar conclusions about the absence of evidence for extraterrestrial technology. Project Blue Book's 1969 conclusion that there was no proof of alien craft aligns with RO current position, that there is no evidence of extraterrestrial technology in investigated cases. This consistency across decades of investigation provides important context for understanding what UAPs are not, even as questions remain about what they are. The evolution of investigation capabilities from the Blue Book era to the present demonstrates remarkable technological advancement. Modern investigators have access to sophisticated radar systems, advanced sensors, computer analysis tools, and international data sharing capabilities that far exceed what was available to earlier researchers. Yet this technological progress has not eliminated the mystery. It has simply provided better documentation of phenomena that continue to challenge understanding. The scientific foundation for future research, the establishment of scientific frameworks for UAP research, represents one of the most significant developments in the modern era. NASA formal engagement, academic involvement, and the application of peer review processes to UAP research have created foundations for systematic, evidence-based investigation that transcends speculation and conspiracy theories. The scientific approach emphasizes data quality, methodological rigor, and intellectual honesty about uncertainty, rather than forcing premature conclusions based on inadequate evidence. Scientists acknowledge what is not yet known while working systematically to improve observational capabilities and analytical methods. This scientific foundation provides the best hope for eventual understanding of UAP phenomena. Whether these phenomena ultimately prove to represent advanced technology, natural processes not yet understood, or something else entirely, the scientific method provides reliable pathways toward accurate conclusions based on evidence rather than assumption. The interdisciplinary nature of UAP research brings together expertise from multiple scientific fields, creating opportunities for advances that might benefit broader scientific understanding. Even if UAPs prove to have conventional explanations, the process of investigating them systematically contributes to technological development and scientific methodology. The importance of continued investigation, the persistence of unexplained cases, despite decades of investigation argues for continued rather than discontinued research efforts. The improvement in documentation and analysis capabilities over time suggests that sustained investigation may eventually yield insights that were not possible with earlier tools and methods. The systematic collection of high-quality data remains the foundation for any eventual understanding of UAP phenomena. Each well-documented case adds to the database that supports pattern recognition, statistical analysis, and theoretical development. The accumulation of evidence over time increases the likelihood of identifying the consistent patterns that might reveal underlying explanations. Technological advancement continues to provide new capabilities for detection and analysis that were unavailable to earlier investigators. Space-based sensors, artificial intelligence analysis tools, and international data sharing networks create opportunities for observations and insights that previous generations of researchers could not achieve. The institutional support now available for UAP research, including government funding, academic involvement, and international cooperation, provides resources and legitimacy that enable more comprehensive investigation than was possible during earlier periods of official skepticism or secrecy. Rational approaches to enduring mysteries. The approach to UAP research exemplifies how rational, scientific methodology can be applied to phenomena that challenge conventional understanding, rather than abandoning investigation when quick answers are not forthcoming. Systematic research continues the patient accumulation of evidence and refinement of analytical methods. This rational approach recognizes that unusual phenomena do not require extraordinary explanations until conventional possibilities have been thoroughly exhausted. The systematic identification and elimination of mundane explanations for UAP reports strengthens confidence in the anomalous nature of cases that remain unexplained. The commitment to evidence-based conclusions, even when those conclusions must acknowledge uncertainty, demonstrates intellectual maturity and scientific rigor. The willingness to say we don't know, but we're investigating systematically represents a more honest and productive approach than either dismissive skepticism or uncritical acceptance. The rational framework also recognizes that mystery and uncertainty are natural parts of scientific inquiry rather than problems to be avoided. The frontiers of human knowledge inevitably include phenomena that are not yet understood, and systematic investigation of such phenomena drives scientific progress. Demystifying through science and technology. The demystification of UAP phenomena proceeds through the systematic application of advanced scientific and technological capabilities, rather than through speculation or assumption. Modern sensor networks, artificial intelligence analysis, and international cooperation provide unprecedented tools for observing and understanding aerial anomalies. Advanced satellite constellations, sophisticated radar systems, and other detection technologies create opportunities for comprehensive monitoring of airspace that could eventually document UAP phenomena with sufficient detail to enable definitive analysis. The deployment of such systems represents a technological approach to resolving persistent mysteries. Machine learning and artificial intelligence tools can process vast amounts of observational data to identify patterns that might not be apparent to human analysts. These technologies offer the possibility of recognizing signatures or characteristics that could lead to understanding of UAP phenomena. International scientific cooperation enables coordinated observation efforts that can provide multiple perspectives on the same phenomena. When similar observations are made independently by different countries using different detection systems, the consistency of results strengthens confidence in the reality and characteristics of observed phenomena. The question of cosmic solitude UAP research inevitably intersects with fundamental questions about humanity's place in the universe and the possibility that we are not alone in our cosmic environment. While current evidence does not support conclusions about extraterrestrial origins for UAP phenomena, the systematic investigation process contributes to our understanding of these profound questions. The search for evidence of non-human intelligence, whether through UAP investigation or other scientific programs, represents one of the most significant scientific endeavors of our time. The methodological approaches developed for UAP research contribute to broader efforts to understand our cosmic context and the possibility of other intelligent life. The absence of evidence for extraterrestrial technology in current UAP investigations does not resolve questions about the existence of non-human intelligence elsewhere in the universe. These are separate questions that require different types of evidence and investigation, though they share common methodological approaches and scientific frameworks. The rational, evidence-based approach to UAP investigation provides a model for how humanity might approach other profound questions about our place in the cosmos. The commitment to systematic inquiry, rather than speculation, ensures that our understanding develops on solid foundations rather than wishful thinking or fear. Technology and human understanding the investigation of UAP phenomena drives technological development in sensor systems, data analysis, and international cooperation that benefits multiple areas of human endeavor. Advanced detection capabilities, sophisticated analysis tools, and coordinated investigation networks contribute to scientific and technological progress, regardless of what UAPs ultimately prove to represent. The challenge of documenting and analyzing ephemeral, unpredictable phenomena has spurred innovation in automated detection systems, real-time analysis tools, and data correlation methods. These technological advances have applications beyond UAP research in areas such as aviation safety, atmospheric science, and space observation. The international cooperation fostered by UAP research demonstrates how shared scientific challenges can bring nations together in productive collaboration. The frameworks developed for UAP data sharing and coordinated investigation may serve as models for addressing other global challenges that require international scientific cooperation. The integration of multiple scientific disciplines in UAP research illustrates how complex phenomena require comprehensive approaches that draw on diverse expertise. This interdisciplinary methodology may prove valuable for addressing other challenging questions that span traditional academic boundaries. Looking forward, the next chapter as we look toward the future of UAP research, several developments are likely to shape our understanding in the coming years. Improved sensor technologies will provide better documentation of aerial phenomena, while artificial intelligence tools will enhance our ability to analyze large datasets and identify meaningful patterns. International cooperation will likely expand as more countries establish systematic UAP investigation programs and share their findings with the global research community. This expansion of investigation capabilities increases the likelihood of documenting and understanding phenomena that might be missed by regional or national programs alone. Scientific acceptance of UAP research as a legitimate field of inquiry will probably continue to grow, attracting more qualified researchers and institutional support. This growth in scientific engagement promises to accelerate progress through the application of rigorous methodologies and peer review processes. The establishment of permanent monitoring systems designed specifically for UAP detection could provide the continuous, high-quality observations needed to advance understanding significantly. Such systems would represent a major investment in systematic investigation capabilities. The value of uncertainty throughout our journey. We have seen how the acknowledgement of uncertainty, rather than the pretense of premature certainty, serves the cause of genuine understanding. The willingness to say, "we don't know," when evidence is insufficient, represents intellectual honesty that provides a solid foundation for continued investigation. The comfort with uncertainty that characterizes modern UAP research reflects a mature approach to scientific inquiry that recognizes the boundaries of current knowledge while working systematically to expand those boundaries. This approach serves as a model for addressing other challenging questions where easy answers are not available. The patience required for systematic investigation may not satisfy those seeking immediate resolution, but it provides the best foundation for reliable, lasting understanding. Science advances through careful accumulation of evidence and gradual refinement of theories, rather than through spectacular breakthroughs or dramatic revelations. The ongoing mystery of UAPs reminds us that the universe still holds secrets waiting to be discovered through patient, systematic investigation. This reminder of the vastness of what we do not yet know serves to maintain humility and wonder that drive continued scientific inquiry. A model for approaching the unknown. The transformation of UAP research from speculation to science provides a valuable model for how humanity can approach other unexplained phenomena or challenging questions. The principles that guide modern UAP investigation: systematic data collection, rigorous analysis, international cooperation, and intellectual honesty about uncertainty, can be applied to various frontiers of human knowledge. The emphasis on evidence-based conclusions rather than predetermined beliefs demonstrates how scientific methodology can be applied even to phenomena that challenge conventional understanding. This approach ensures that progress is built on solid foundations rather than speculation or wishful thinking. The international cooperation that characterizes modern UAP research illustrates how shared challenges can bring together diverse perspectives and capabilities in productive collaboration. This model of cooperation may prove valuable for addressing other global challenges that require coordinated scientific investigation. The integration of multiple disciplines in UAP research shows how complex phenomena often require comprehensive approaches that draw on diverse expertise. This interdisciplinary methodology may serve as a template for addressing other questions that span traditional academic boundaries. The continuing journey. As our documentary journey draws to a close, It's important to recognize that the story of UAP research continues to unfold. Each new observation, each analytical advance, each international collaboration contributes to our gradually expanding understanding of these phenomena. The dedicated investigators who work quietly in laboratories and observatories, the military personnel who document encounters with professional precision, the scientists who apply rigorous methodology to challenging questions, and the policymakers who support transparent, systematic investigation, all participate in humanity's eternal quest to understand the unknown. The night sky above us holds the same mysteries that have puzzled humanity throughout history, but our ability to investigate and understand those mysteries grows ever stronger. Advanced sensors can detect phenomena invisible to earlier observers. Sophisticated computers can analyze patterns hidden in vast datasets, and international networks can coordinate observations across the globe. Yet for all our technological advancement, the fundamental approach remains unchanged. Careful observation, systematic analysis, honest acknowledgement of uncertainty, and persistent effort to expand the boundaries of human knowledge. These timeless principles of scientific inquiry provide the foundation for continued progress in understanding UAPs and other mysteries that await discovery. Final reflections as you prepare for final rest at the conclusion of our 3-hour journey through the world of UAP investigation. Take a moment to reflect on the remarkable transformation we have witnessed. From the early days of Project Sign through the modern era of ARRO and NASA scientific panels, we have seen humanity apply its finest intellectual traditions to some of its most persistent mysteries. The shift from ridicule to serious inquiry represents more than just changing attitudes toward a single phenomenon. It reflects our species' growing sophistication in approaching the unknown with curiosity rather than fear, with methodology rather than speculation, and with cooperation rather than competition. The investigators we have met throughout our journey, from the military personnel of Project Blue Book to the scientists of contemporary research programs, share a common commitment to understanding truth through evidence and reason. Their patient, methodical work exemplifies humanity at its best, curious, persistent, and committed to expanding knowledge through systematic inquiry. Whether UAPs ultimately prove to represent advanced technology, natural phenomena we don't yet understand, or something else entirely, the process of investigating them systematically has already yielded valuable insights into methodology, international cooperation, and the application of scientific principles to challenging questions. The mysteries that float in our skies serve as reminders that the universe still holds secrets waiting to be discovered. The systematic pursuit of those secrets, guided by evidence and conducted with intellectual honesty, represents one of humanity's most noble endeavors. In observatories and laboratories, in government offices and international forums, dedicated researchers continue this ancient quest to understand our place in a vast and mysterious cosmos. Sleep well, knowing that the careful work of investigation continues in the quiet hours. Somewhere in the darkness, advanced sensors scan the skies, computer algorithms analyze patterns in vast datasets, and human minds work patiently to expand the boundaries of knowledge. The journey toward understanding proceeds, one observation at a time, one analysis at a time, one carefully documented case at a time. Tomorrow will bring new observations, new analyses, and new opportunities to advance our understanding of these enduring mysteries. The questions that have puzzled humanity for generations may not be answered quickly, but they will be approached with the full power of human curiosity, scientific methodology, and international cooperation. In this continuing quest for knowledge, we see reflected the best of human nature, Our refusal to accept easy answers when truth requires harder work, our willingness to acknowledge uncertainty while striving for understanding, and our commitment to following evidence wherever it may lead, regardless of how it might challenge our preconceptions. Sweet dreams, filled with wonder at the vast universe around us, and appreciation for those who dedicate their lives to understanding its mysteries. The story of UAP investigation continues, carrying us ever closer to answers that have eluded us for decades, guided by the patient application of humanity's greatest tool for understanding, the scientific method, applied with rigor, honesty, and unwavering commitment to truth.